So let's look at what are we going to do today. We'll look at what is big data. We'll understand what are the limitations of the existing solutions. Why do we need something like Hadoop? Okay, we'll also understand how does Hadoop solve the problem. Then we will be we'll be looking at we'll be introducing you to Hadoop. We'll look at the various components in the Hadoop ecosystem. We'll also look at the core components of Hadoop, which is HDFS and MapReduce. We'll go into details of HDFS architecture. We will also understand how does a MapReduce job execution work. We'll understand terms like rack awareness. We'll also understand how does a file read and write happen in Hadoop. And then we'll also take a sneak peek on the Hadoop 2.0 architecture. Okay. We'll try to understand where MapReduce is used. Okay, what were the traditional ways of solving problems which MapReduce is solving today in earlier days. Okay, we'll also understand how does a MapReduce program look like. We'll do at least 4 Java programs today. Okay, we'll show you 4 Java programs today at least. Okay, we will also discuss a little bit about Hadoop streaming. Okay, which is a way to actually run Java, run code without run MapReduce code without Java. Okay, so we'll discuss a little bit. We'll not go into the detail here. We'll understand the concept of combiner and partitioner, obviously other than the map and reduce. We'll also understand the data flow. We'll understand how the input splits are done, and then some of the input-output formats. Okay, so these are the topics we're going to cover today. Okay, so let's get started, guys. Okay, so what is big data? Now, I'm sure everyone has heard about big data. Everyone has done their own research on big data till now, and they know what is referred as big data. But let me also tell you what big data is according to me. Now, not very different than what you've thought. It's lots and lots of data. That's what it's called. That's why it's called big. Now, it is not in megabytes or gigabytes when the data reaches terabytes and petabytes. And if the data is really large and complex in the sense that it is not not just structured data, a lot of unstructured and semi-structured data is called big data. And there are a few definitions associated with big data where they say that, okay, big data, when you have large amount of data flowing in your system, okay, at a big speed and a big variety of data like big streams from, if you click on something, let's say a like or a share on Facebook, that contributes to big data. Large amount of videos, audios which are shared is called is big data. The amount of data which is the kind of data which is shared in, say, I mean, the amount of data, the customer data which you get, the kind of customer behavior data which you get in large organizations, that contributes to big data. Why are people so crazy about big data these days? What does big data help in? So yes, so this is basically the motivation about, see, everyone had a lot of data. It's not that data has come today, but there was not many ways of analyzing that data. Okay, so with tools like Hadoop coming in, it has become much more easier to analyze that data. Okay, and you can do predictive analysis, you can do trend analysis, you can look at customer behavior, you can run specific campaigns for customers, you can do say a fraud analysis using big data. So lot of domains are finding applications there. It's all started with social media, but now, I mean, right from banks to retail, we will be looking at some examples to government. Everywhere people have started realizing the power of big data analytics, and they are doing analytics there. Okay, so now there is an example here which says New York Stock Exchange generates about 1 terabyte of new trade data per day. So what is big data? Now the first question which comes to us is, why are we here and what is big data? Can someone tell me, I mean, what does Facebook has to do with big data? Facebook wants to make sure that, I mean, as advertisers, right? Edureka also advertises on Facebook. So as advertisers, we want to make sure that the ads reach the right people, right? So that targeting is done based on that. So all preferences which you have, you must be seeing that if you visit a site, after that you see the ads of that site all for a long time, right? So all that is done by managing that big data only. Okay, is that fine, guys? So that's basically a little bit about big data. We'll understand more about it. Now we have a picture on the right. Can anyone tell me why have we put an aeroplane here on the right? Okay, so Vinayak has given me the right answer. Vinayak tells me that system logs in black box. Okay, so everyone knows what is a black box in a airplane. Okay, so basically see, a black box is a part in an aeroplane where it will be recording everything which is happening. Okay, whether it is flight information there, whatever system changes are happening in your speed, and everything will be noted down. You don't, it stores huge amount of data in terabytes, not something which will be used every day, but in case of any eventuality, if there is an accident or a crash, then that is the only part which will be looked at, and they'll try to do analysis that what happened and how to avoid that in future. Okay, so that's also huge amount of unstructured data. Okay, so then we have this electricity thing here, grid here. Now again, here in the electricity grid also there is huge amount of I mean, you must have heard people in India suffer that a lot. Abhishek is probably not prone to that as much, and he's immune to that, but then people in India have to face these power failures. I might be teaching you in another hour in a completely situation where it is there's no power, but hopefully so basically you have to, there's a lot of data here as well. I mean, all the nodes, where substation, which grid point, where the electricity is being routed, okay, where is the consumption. So all that huge amount of data, right, is something which is there, which we have to analyze. If we analyze that properly, we'll be able to probably route things properly. Some people from Karnataka and Tamil Nadu here in India will be knowing, right, the fight which is happening all the time, right? If we could use a good level of analytics, probably a lot of things could be saved there. So that's where in the real life a big data analytics is going to help. And the reason I have put all these examples here is because you will be seeing in utilities, you will be in say utilities, you will be using big data analytics. Now the Aadhaar scheme which is there in does everyone know about Aadhaar in India? That also uses Hadoop. Okay, so Abhishek, Aadhaar is like a social security number thing here, which has been started in India with a special biometric card. Okay, so it's like a SSN for you. So there also all the citizens are being mapped, and I mean, I'm sure everyone else has looked at it, and so there also we use Hadoop. Okay, so you'll be seeing going forward there are a lot of places where Hadoop will be used. It is just coming up now, and then in the next few years you'll see everywhere this application will be coming in. Okay, so now on the right hand side I've put this files here. Can someone tell me why is this here? Now yes, it is unstructured data, it is physical data, and government office files is what Rahul tells me, right? So these government office files have to be, if you could actually get them into Hadoop, a lot of things would have been solved. So now we understand, I mean, a little bit understanding is there that what is so now do we know the difference between unstructured and structured data? Can anyone answer that? That's very important to understand here. So what is structured and what is unstructured? Can someone answer that question? I'll obviously tell you that. Okay, so Abhishek tells me that structure is tables and columns, right? Vijay, who is I really like your answers, Vijay. Vijay is telling the difference is un. Okay, good question, good answer. So structured is in tables. Structured could be in tabular format, columns and rows, right? And Vijay also tells me, now Vijay has gone a little deep. He tells me schema. So yes, a fixed schema is something which, or a schema is something which is a characteristic of a structured data, right? Very nice. This unstructured data is something which has been growing a lot in the past few years. Okay, in the past few years we've seen that lot of unstructured data is being dumped by, it started with social media companies. Now almost all the companies are actually getting there, and the challenge is to analyze that. Okay, and it is growing really fast. We'll see in the next few slides how does that grow. So now if we go forward, so this is a Facebook example where we see that, okay, there's so many people on Facebook. I can't even read this. It is probably 500 million active Facebook users. Okay, in 2011. So I'm sure it will be 1 billion by now. There's so many, so 1 out of every 13 people on earth. I'm sure this is an old one, so there will be many more people. The idea is to actually give you a view on not exactly these numbers, but to just to show you that the huge amount of data which is being dumped every day. So these many links are shared every day, these many friend invites, you tag photos, status updates. Facebook has to actually do analysis of everything here, okay, and it becomes very, very difficult. We'll see what are the challenges just in a while, but here in this slide I just want to show you that, okay, this is the kind of data we are talking about. Okay, few years back this was not the case. No one was actually analyzing this data. Now there are a lot of manufacturing companies in India who will be getting this amount of data, but they will not be able to analyze it, okay, and therein lies the opportunity. Okay, there will be a lot of utility companies, the oil companies, the electricity companies who also have that data, but then analyzing that data is the challenge which every company is facing, and that's why we are having this class today, right? So you get a feel of what is Facebook up to, right? If we go ahead, let's see another example and see what is now Twitter again, right? Again, a social media company. So Twitter has what? Twitter has 500 million registered users. Okay, so in USA, I'm not a big fan of these stats, but then I mean these have been taken from some blogs. The whole idea, the crux of the matter here is that a lot of people are there, a lot of activities happening, and one very important thing here, why we are doing all this analytics is 79% of US Twitter users are more likely to recommend brands they follow. Okay, and 67% of US Twitter users are more likely to buy from brands they follow. Okay, so that's the idea, and that is why this is so much important. It's not just sheer fun. Facebook or Twitter, now they're serious business ways. I mean, I'm sure a lot of you guys must be using Twitter and Facebook as their marketing, as the companies must be using as their marketing engines, right? So basically, and they need to do a lot of analytics. They need to understand which users to target, whom to target, what time of the day to target. So all that analytics, say for example, if I run an ad at 4 p.m. in the afternoon in India time, most of the people in India will be working at that time because that is the time when everyone works, right? Sure, Vijay, I think it is Edureka. You can use that, and then so now a lot of people, but if you target an ad at say for example 6 o'clock in the evening, okay, a lot of people will be traveling, so they may not be on their systems, and that may not be a good time. So when is a good time, which is a good time, what type of audience are available at what time, all this is the analytics which we want to do with the data which we have, right? Is that clear, guys? Does that make sense? And is this something which you've understood properly? Can I quickly get a round of smileys if everyone has understood it? Or if you have any questions, I can quickly answer them as well here. Great, Vikas. Thank you very much. Great. Thanks, Anup. Okay. So I understand everyone has got the idea. Two things which I wanted to make clear from last few slides was that one, the rise of unstructured data, the difference between structured and unstructured data, the kind of industries where it is applicable and where it is happening, the dumping of the data, okay, and some examples of the companies which are actually doing big data analytics and they are successful. Okay, so Facebook and Twitter are two such companies, right? So if that is something which you've understood, that is all I wanted to convey from these foils. Okay, the numbers, exact number, it is 79% or 67%. That is for I don't know which exam will ask you. If they ask you, don't answer that question. You can ignore it. Tell them that I don't want to answer that. If you've got the idea, right? Okay, so okay, very good question. Is Hadoop only for unstructured data? Does it also work on structured data? Is what Abhishek has asked me. Now, Abhishek, for unstructured data, largely Hadoop is used and HDFS is used. There's something called HBase in Hadoop. We will come to that later. We do analytics on structured data as well. Going forward, there will be a time when all type of data could be analyzed using Hadoop. It started for unstructured data. Okay, is that clear, everyone, and Abhishek? Great. So the whole idea is if we can distribute things, okay, and I'll tell you why it is required in just a short while. Okay. Great, Shyam. Thank you very much. Okay, now let's go. Let's move ahead. Everyone knows Instagram. Is there someone who doesn't know Instagram? Okay, so Instagram, I mean, Instagram again is one of the big successes of the social media time, and I mean it's a app, it's an app which takes pictures, and the difference is just can someone tell me what is the difference between, say, a Facebook picture click and share, and between Instagram picture click and share? Anyone who knows that, who has been using Instagram? While others can read through this slide and see Instagram gains one new user every second. Okay, Instagram was sold to Facebook probably for $1 billion, right? So Vinayak tells me it has image filters, right? So something which you could do in Photoshop earlier, I mean some of that part can add effects in Instagram, right? So that was just a small innovation which Instagram did, and it became an instant hit on internet. Okay, so that's, and then so many 1 billion photos have been taken with Instagram. So you can imagine the kind of data which Instagram has to handle, and with all those effects and filters, it becomes huge, right? So that's again one company which will be using a lot of big data analytics. Okay, and there are many more such companies. We'll come to that as well. We'll know. I'll also tell you a link from where you can go and read what all companies are using Hadoop and what do they do with Hadoop, what is their cluster size. All that information is also available in public domain. Okay. Now there's one slide which actually tells you about that. There's AOL, there's eBay. They use for different reasons. I mean, I want you to actually go through this. I'll share a link with you. Facebook, for example, let's talk about Facebook. Okay, Facebook uses Hadoop to store copies of data. Okay, and they do machine learning as well. So I'll tell you a little bit about machine learning in just a while, but not in detail. Now it has a 1100 machine cluster with these many cores, right? So each commodity node, what is commodity is something which you should think about right now. I'll tell you just in a while. Okay, so they use 8 core and 12 TB of storage on each machine. Okay, so this is a typical data node in I'm using the term data node. I'm just using the liberty of using the term data node. I'll explain that in a while. Okay, so has 8 cores and 12 TB of storage. Okay, this is the storage capacity of each node there in the cluster. It has a 300 machine cluster with this kind of thing, right? So basically, and then we have eBay, which has a 532 node cluster. Okay, heavy use of Java MapReduce. So MapReduce is the programming model there, Pig, Hive, HBase. All these tools, guys, we'll learn in this course. Okay, so if you understand this well, you'll surely have options to moving into any of these companies. Now eBay uses for search optimization and research. Okay, now on eBay, if you go to eBay and if you look for some product, okay, there'll be thousands and lakhs of products there, different search. You should be able to search them on various terms. So that is where Hadoop is used there. Okay, let's move ahead. Anyone has a question here, and shall I move ahead if this is clear? Quickly, can you quickly say a yes or no? Okay, Anup tells me yes. If no, I mean it's okay if you don't write. I'll assume that we can move ahead. Okay. Don't let you type. Sometimes I'll force you to type so that you are not sleeping. Okay, just to make sure that you're not sleeping. Okay. Okay, now we have this data volume growing exponentially. Now what does this mean? Okay, now we've been talking about a lot of companies till now. Now this is one infographic. It has been taken from EMC here, which shows the amount of data which is growing. Now 1 terabyte is here. Okay, so this is 1 terabyte of data. What we're talking about are zettabytes of data. Okay, which is 1 billion terabytes. Now some estimates said that to 1.8 zettabyte will be there. These are again old slides. So I mean the whole idea is not to know these exact numbers, but to understand the amount of data which we're talking about, and this is very important. The world's information doubles every 2 years. Okay, in the next 10 years, this is the opportunity. So this is where the opportunity lies. Now all of us who are working in this big data domain, and a lot of you will be working on that going forward, whether you like it or not, most of the people here in India as well as in the US will be working with big data in some form or the other in the next 5 to 6 years. Okay, so you guys could be early adopters there. And and the reason why I've put this foil here again is to tell you that this is how it's going to grow, and everyone will be a part of this revolution. Big data analytics will be a part of it, whether you like or you don't like it. So it's better to actually understand things now and be early adopters there of this technology. Okay, great. So yeah, so Narayan has told me yes, sure, and I think I lost the chat window. No one has said yes. Okay, sorry. Okay, so guys, so this, anyone has a question here, or I'll move ahead. So basically, till this time, I'll just rephrase and I'll make sure that everyone understands. We talked about unstructured data, right? We talked about the different companies which may be using the unstructured data. Then we also talked about some of the companies which actually became very successful using big data analytics. Okay, and we also showed you how the data volume is growing now. There's another infographic, and after that we'll move on to why Hadoop. Okay, this is important again. I mean, okay, now Vikas is asking me a question. Can we can use Hadoop for structured data as well? Well, because the same question was asked just a while back by Abhishek. Yes, you can. Yes, you can. There are some limitations, but you can. Okay, and we will. HBase is the component of Hadoop which is used to store structured data. Okay, now that's not really completely like your relational database. It's a different kind of database. We will be talking about it when we reach HBase. But yes, that's true. You can use it. Okay. And as we go ahead in a year or two, you will see that there will be provisions where you can completely replace your MySQL with a Hadoop kind of thing. People are working on that. Okay. Now this graphic shows you how the overlap has happened between structured and unstructured data. So in the times of when Shah Rukh Khan came in or Maine Pyar Kiya came in 90s, there was no unstructured data. Okay, it's only after that unstructured data grew. And the age of Ranbir Kapoor, this is the situation. Okay, so now and relational databases are, relational data or structured data. See, the fact is that this data is also growing, but the speed at which this data is growing is something which is phenomenal, and that is where the challenge is, and that is where the opportunity is. Okay, so let's move ahead if everyone is fine here, and let's see a few more things. We'll do a small exercise also now. Okay, so now we've seen that huge amount of data is being stored. Okay, now the challenge probably, is not the storage. You have storage capacities have scaled up beautifully, right? The challenge is something else, and let's try to see what that something else is. If you've seen this presentation earlier, then probably this is a very easy question to answer, but still I want everyone of you to actually answer this. We have this one machine here which has 4 IO channels. Each channel can run 100, do 100 Mbps of input and output. How much time will it take to do a 1 terabyte of transfer? Can someone tell me that? Can everyone tell me that? I'll give you say 30-40 seconds to calculate that. Okay, Abhishek has given me an answer. Okay, Vinayak has given me an answer. Tell me, okay, guys, when you write this answer, also tell me if you've seen this earlier or not. Okay, if you're calculating here, okay, everyone is giving me good right answers. The first time, I'll tell you guys, for the first time when I showed this thing, okay, no one actually answered this question right. The few people did, and you'll also have to tell me how did you calculate this. So I want answer from everyone. Anup, Vikas, everyone has to answer this. Okay. And do not worry if the answer is wrong. Okay, it doesn't really matter. And that's not the purpose of doing this exercise, whether to get the right answer or not. Okay. The purpose is for you to actually calculate and understand. Okay. Abhishek has given me a big calculation. Abhishek, it must be right only. If you've done such a big calculation like a old professor, I'll say, yeah, you have done it right. So like the time in college, right, we used to fill in a lot of things so that the professor thinks that this guy knows something. So we'll give him some marks. I'll give you marks like that. Okay. Everyone else, are you guys calculating it? You want some time to calculate it? Okay. So I'm still waiting for answers from Rahul. Shyam, Rahul has given me, great. Okay, no problem. Sure. Thanks. Rahul has given me an answer. Shyam has given me an answer. Dayanand, are you with me? Vijay has given me an answer. Vijay always comes with, Vijay, what is that? 400/4000. Say, give me answer in minutes here. I'm bad at calculation. I'm very bad at maths. I'm not. I'm actually decent in maths. A lot of other subjects I'm very bad at. Okay. Okay. Dayanand, are you calculating? Yeah. Vijay, you can use a calculator, man. If you, I will not use a calculator in front of you. Guys, you can always use Google for answering, okay, if I ask questions. And the reason why I tell you that is because it's not only from here which you are learning. You can, if you Google things, you will probably get a lot of other perspectives as well. So Prahlad has given me some answer which reads into 10737418 seconds approximately. Prahlad, uh, looks like something which has gone above my head. Okay, but never mind. Uh, just important thing is to understand that it takes a lot of time. Okay, Sham has given me the right answer. Sham has told me how to calculate that, and thank you very much, Sham. Sham tells me 1024 into 1024 divided by 100 divided into 4 and divided by 60 is the answer in minutes. Yes, that's right. So Dayanand, are you there? Are you actually calculating it? Okay, great. So see, the answer is 1 terabyte. So 1024 into 1024 MB is 100 MB per second what it is able to do. So 1 terabyte will be 1024 into 1024 MB divided by 100, also divide by 4 because there are 4 IO channels. You can do 4 reads in parallel, and then divide by 60 as Sham has rightly said and a lot of other people have said. So it approximately takes around 45 minutes to do that. Okay, right? So now the whole idea is not to actually make you calculate this, but the idea is to show you that for 1 terabyte of data, okay, it is taking so much time to actually read it. Now what do you have to do in real life? All this data is dumped somewhere. If you have to read it back, you have to read it back multiple times, right, to do analytics, right? Is that right, guys? Yes or no? Is this making sense? Yeah. So if it takes for 1 terabyte, it takes so much time. When we talk about zettabytes of data, think of it this way. If Facebook had to read it in this manner, what analytics would they be able to do? Every day they have 500 terabytes of data, and that is old estimate. Okay. So a traditional way of doing things like this, vertically vertically scaling thing means, for the people who don't understand this jargon, I really don't like these jargons. Vertically scaling means that you improve the system, put a better machine, improve storage in a system. So vertical scale is not going to help. Put more expensive machine. Okay, that's not going to help much. Is that clear, everyone? So the solution to that is something like this. So imagine if you could do the same thing, if you could partition that data and put it into 10 different systems, how much time will it take? Now I want this answer in 10 seconds. Everyone has to answer. Vijay, you don't need maths here, man. Okay, so now everyone has given me the right answer except Vijay. Vijay is not answering. Okay, I'm saying if we had 10 machines here, okay, if we partition this data and put it into 10 machines, how much time will it take to read that complete data? Yes. So yes, the right answer is yes. If we could do it, if we could actually do it, yeah, 45 by 10 is the right answer. Now that's a very, very simplistic view of saying things. This could be one solution. Now vertical scaling is not going to help. That is clear, right? We understood. Even if I add say 10 channels here, not possible. The maximum speed of SATA 2, which is the hard disk standard, is how much? Like 500. I believe it is 500 MB per second, or SATA can read it in, I believe SATA 2 can do it in 500 GB per second, and that's gigabits. Okay, so that's not, those things are not going to help much. Okay, you cannot go 10 times there. So probably a good solution and a solution could be horizontal scaling, which means add more machines. If you can partition this data, do it in a distributed way. So now around 10, 15, 20 years back, there was a time when this grid computing or distributed computing or parallel computing was very much in thing. Okay, and so there is a difference between grid computing and what we do here, right? Okay, so that time the challenge was CPU speeds. So you wanted to distribute the compute, if you have a big equation to solve, which you cannot solve in one machine, you distribute it across clusters of computers and let those clusters actually solve that and give it back to you, right? This is what we used to do earlier. Okay, when we, is everyone in sync with whatever I said now? Quickly a smiley if everyone has understood. Okay, S is also fine. If someone has not got it, please tell me. Great. So at that time, one solution which we, yes, great. So everyone is in sync. Anyone who is not, please do let me know. Okay, and I'll really appreciate. Okay, Dayanand, no problem. So Dayanand wants me to repeat this. So Dayanand, I was saying that there was a time earlier when computation speeds were a problem. Okay, so you were restricted by computation speed. So if you had a big problem to solve, today also that problem is there, but that the computation speed problem came much earlier than this problem which we are talking about today. Now, so at that point of time, what we did was we called something called parallel computing or distributed computing. I'm sure everyone has read, and anyone who's from a computer science background has read that theory subject distributed computing, which no one understood why it is there, and you had to write a big answer, what are the advantages of distributed computing. So go back to that, think about it. So that was the time when challenge was CPU speeds, and that time what we did was we distributed a particular task across various machines and then got a consolidated answer. Okay, so that's how we used to do that problem there. A similar problem now is not in computation. So this is not parallel computing. Okay, what we're talking about is not parallel computing, but this is distributing the data across multiple channels. Okay, and it's not because of the computation speed, but because of the IO speeds. Okay, so this is the difference which I want to bring out here. Is that clear to everyone? Can I quickly get a yes or a smiley from everyone if you've understood the difference between parallel computing and what I'm trying to tell you here? Great. Thanks, Vijay. Vijay says perfect. Thank you very much. Great. So guys, you can keep encouraging me sometimes. Okay, but yeah, I mean, fine. Thanks. So great. So Anup is probably not answering. Anup, are you liking the class, or you want me to change something here? Or you're doing something else as well? Okay, great. So Anup, I'll really appreciate if you can just quickly keep writing things. Yes or no, everything is fine. I want to make sure that, yeah. No problem, no problem, Anup. So you can see the chat window, right? So no problem. See, if this class, I am never limited by time. Okay, I have a lot of time. If after this class also I can be online for a one-on-one session with any one of you who has not understood something. Okay, just I'm never limited by time. Okay, I'm never constrained. I have a lot of time in my life. Okay, so please make sure that you ask me questions. Everyone here in the class has already said that they're okay if we go a little slow this time. Okay, from this week onwards, you'll have one more week to full week. You can ask questions. You can get up to speed. This is the first class, so we can be slow. Okay, Anup, is that fine? So anything if not understood, please feel free to ask. I can also unmute you if it looks like, if it is a little difficult to actually answer questions, write questions on this chat window initially. Okay, I can unmute you and you can ask questions. Okay, sure, great. So, and don't worry, all of us are new to this. I am also new to this. I also learn a lot of things in the class itself. And Vijay, Prahlad, everyone, please make sure that if there is anything which is a doubt, don't keep that doubt with you. You can ask me. And for some things, if you want, any one of you who wants to speak to me after the class as well, one-on-one on Skype or something, we can do that as well. Today itself, we can do all the doubts. Okay, guys? Thank you very much. Vinayak and everyone, is that fine? I mean, I hope everyone understands that there will be some people who will be completely new, who would be coming in this class, who would have actually enrolled for the course last night and just thinking that I'll also learn something. So we just want to make sure that we are with everyone. Okay. So if this method of teaching is fine with everyone, I quickly want a yes, right? Great. Thanks, Abhishek. Abhishek is saying great. Thanks guys. Okay, fine. So we'll just go a little, we'll go a bit extra with everyone today. Next time onwards, we'll be a little fast, but we'll make sure that everyone with us. That's why we have a limited number of attendees in the class, right? So we can handle everyone. Now this class is actually, I can handle 15, 16 people. Now they have 11, so it's not all that difficult. Okay, great. So now everyone has understood the fact that the challenge is not in storage space, it is not in computation speeds, it is in the IO speeds, right? Yes or no? Quickly, a smiley or a yes. This sentence which I said, everyone is crystal clear with this? Because this could be one question which can be asked to you in an interview. If someone comes to me for an interview, I ask this question. Okay, so please make sure that you understand this. Great. So the challenge is not this. Okay, Suman has given me a smiley. Thanks, Suman. Okay. Now, so a probable solution is distribute the data across multiple machines. Okay, and so I just gave this answer here. Now let's see what is distributed file system. Okay, now when we agree that distribution is the way, how do we do it? Let's understand that. Okay. So this is a picture here which shows you how actually a distributed system looks like. Okay, distributed file system looks like. So here we have different machines at different locations, physical locations. Chicago, there is one machine. See, I mean some example. Don't worry whether it is Chicago or Denver or Bangalore or say what. Say Noida, it doesn't really matter. Okay, so these are machines which are kept at different physical locations. Now when you do a DFS consolidation, which means when you make a distributed file system out of this, Narayan, what are you doing when you are not looking at the slide? I have a tool to know who is not attentive, so come back. Okay, I play this game in God mode. Okay, Narayan, so you have to be attentive here. Okay, Vijay has gone non-attentive. Okay, Suman has gone offline. Okay, no problem. So yeah. So now once we do this DFS consolidation, then though these machines are still at different locations, but on a logical level, they look like directories in a single file system. Okay, is that fine? So this is what DFS or a distributed file system is. So say machines will still be at different locations, but on a logical level, if to a client, to a user, it will look like different directories in the same file system. Fine, is that okay, guys? So this is about how does a distributed file system look like? Okay. Okay. So what is Hadoop? Now we've understood what is big data. We've understood what is the need of unstructured data. We've also understood that the challenge is not to store data, but to read-write data, to analyze data. And we've also understood to do something like this, we need something which can support a distributed file system. Okay. So Hadoop is actually a framework which solves this problem. Okay. So all of you understood the need for Hadoop now. Can you quickly give me a yes? I'll understand what is you'll understand what is Hadoop, but has everyone understood the need for Hadoop? Anyone who is not? Okay. Can I get a smiley from everyone? Okay. A lot of people are writing and smiling as well. Okay. Okay, so Rahul says, can you repeat? Rahul, are you joking with me or you really want me to repeat? Okay, so I'll just repeat it for the sake of Anupam and everyone. So see, basically, who've joined late, we've understood right from the first slide that what is big data. We've understood that. So we have huge amount of data, unstructured data getting dumped in some places. Okay, then we understood that the challenge is to analyze this big data, we have to read it back. Okay, Rahul, please pay attention here. Now, the challenge is not to store the data and how to store the data. Technology has scaled up there. The challenge we saw was to read that data back, okay, to do analysis on it. And then we understood that reading it from a single place is not going to solve the problem. So we understood that there has to be some distributed way of storing this data. And then we understood what a distributed file system is. And now, so we know that there is a need for something which can solve this problem of storing data in multiple nodes across a cluster. So is that clear to you, Rahul? That is why we need Hadoop. Great. So that is okay. Great. So now the need of Hadoop is this. Everyone has understood that. Let's see what Hadoop is. I'll go with a formal definition of Hadoop, and this will. I promise you that this is the last formal definition I will talk about in my whole life after this one. Okay. I hate formal definitions, but this time I had to put this in. Okay. So Hadoop is a framework that allows for distributed processing of large data sets or running on commodity computers using a simple programming model. Okay, so now there are a few things which have to be noted here. Okay, that's why I put this definition. So Hadoop is a framework that everyone understands of distributed processing of large data sets. So Hadoop is useful only when you have large data sets. Okay, if you have small files, it is not of use. So this is a very important thing, large data sets, and that too unstructured data. Okay, across clusters of commodity computers. Okay, I'll make you understand this term also, commodity computers. So basically, Hadoop does not require the nodes on the Hadoop side need not be high quality, high availability machines. They can be simple hardware, commodity hardware. We'll understand this in more detail using a simple programming model. So the simple programming model is called MapReduce. I will not explain you anything about MapReduce today in today's class, but you just try to understand that there is something called MapReduce. Just get this term in your head. In the next few classes, we'll understand that in more detail. Okay, is that clear to everyone? So it's a framework for distributed processing, large data sets, commodity computers, and simple programming model. So we will understand each and everything in detail going forward. Is that clear to everyone, guys? Anything which you do not understand here? It's very important to understand this. Great. So yeah, I think everyone has understood it. Okay. So good. Thank you, guys. If you keep on giving me these yes or smiley, I know that I'm doing a decent job here and you're not getting bored. Okay, so please do not hesitate to write that. Okay, thank you very much, Ajay. Mohan is not doing that. Mohan is not happy anymore. Okay, don't worry. There are enough people to keep me going. Sayyad has given me a smiley again. Thank you, Sayyad. Okay. Mohan is saying not true. Mohan, you can just give me a smiley, man. Okay. So now companies using Hadoop. Now this is again a question which people ask. Which are the companies which are using Hadoop? So I'm sure a lot of we had Sandeep from Yahoo, right? Okay, no problem, Mohan. Please take your time. Okay, so Sandeep is from Yahoo. So Sandeep, Yahoo is a company which uses Hadoop. Google uses Hadoop. Facebook uses Hadoop. Amazon, IBM, AOL, a lot of other companies. You can find that here. I mean, LinkedIn also uses Hadoop. So basically, the funda is that any company which has to do a big data analytics, and we have an expert on big data analytics here, Ajay. Ajay, can you tell me one Indian company which is using Hadoop? Ajay, okay. So Google says, okay, yes, Vidyasagar, that's right. Google had released their own version of DFS. Sure, Rohit, not today, but definitely we will understand it. Okay, not today. Okay. Cloudera is not Indian company. Thank you. Okay. So with Vidyasagar, yeah, Hortonworks is also not Indian, I believe. EMC is also not Indian. Well, I have been told that the Aadhaar scheme is going to use Hadoop. Okay. So Aadhaar scheme, everyone knows about that. Does everyone know about that? Okay. So Aadhaar scheme is going to use Hadoop. So that will probably one. Okay. So now guys, there may be some answers which I may not be able to give you right now. And the reason why I don't want to give those answers is maybe they will take you a little off topic. So I'll not answer them right away. You can always write those answers on the chat window. We'll respond them offline. And also, if needed, we will be covering a lot of those things as we move on in these sessions. Is that okay with everyone? Okay, cool. So yes, these are the companies which use Hadoop. Okay, so now let's move forward. Now I have this is the first technical diagram on my slide. Okay, and I want every one of you to actually look at it for some 10-15 seconds, and don't worry too much about it for now. I bet that by the end of it, you will all become experts in this. Okay, so Hadoop basically has two core components. Okay, I want all of you to actually look at this pay a lot of attention here. Okay, because this is the first time when we are talking about Hadoop, and that's why you've paid for. So if you don't understand this, there's no point in your making this payment to Edureka, which is, by the way, doing very good these days. I've seen the kind of attendance and the kind of demand there is. So just joking, I'll ask them for a hike. So yeah, so basically we have two major components. One is the HDFS, which is the Hadoop distributed file system, and the second one is MapReduce. So distributed file system is used for storing, and processing is done by MapReduce. We will talk about MapReduce later on. in the next few classes, not today. On this diagram, there are two things which are very important to note. We said there is a, and I'll not explain it here, okay. Just note that there is something called a name node, which is the admin node. It's a master slave kind of configuration. So there is something called an admin node or a name node, which is the master, and then there are slaves which are called data nodes, okay. And then there is something called a job tracker. You have to remember these terms. Don't understand them, just remember them, which is associated with a name node. And there is something called a task tracker, which is associated with a data node. Okay, is that clear to everyone? You don't have to understand it completely. This is what we are here for. We'll understand it by the end of this session. For now, just remember that there is something called a name node and a job tracker which is associated, and there is something called a data node and a task tracker which are associated. Okay, and name node is the master and data node is the slave. Is everyone clear with that? Quickly, can you give me you don't have to understand it completely. Even if you don't understand it completely, if I ask you a question, what is name node associated with? If your answer is job tracker, then you're good enough for this slide. Okay. So can everyone quickly answer what is name node is the master? Rohit gives me the answer. Name node is the master, and there's a job tracker associated with it. What is the job tracker? What is the name node is something which we'll cover. Good. Great. So yes, so data node is a slave and this. Okay, so there's another term here. Don't worry, Sandeep, I'll explain it. Sandeep asks me what is the difference between MapReduce engine and HDFS cluster. Okay, so basically HDFS cluster is the name given to this whole configuration of masters and slaves where this data is stored. Okay, so that is the HDFS cluster. So this whole thing is a HDFS cluster. MapReduce engine is the programming model which is used to retrieve and analyze this data. Is that clear? And I'll not tell you anything more than that in this. You don't have to understand anything more than that. If this much is clear, you will understand everything going forward. I'll not go into more technical details right now. So 2-3 things on this slide. One, there's something called a name node, associated job tracker, something called a data node, associated task tracker. Then we have a HDFS cluster, which is the combination of these name nodes and data nodes. And then we have a simple programming model, which is called MapReduce engine. Is that fine, everyone? Can I quickly get a smiley from everyone other than Mohan, because Mohan does not want to give that. Yes, Rahul, you're right. Rahul is asking me job tracker as task tracker, and task tracker all are separate machines, total 5 in this picture. So yes, a task tracker is associated with each data node, so multiple data nodes and single name node. That is the very minimal configuration. We will talk more about it as we move forward. Okay, so I've got a smiley from everyone. Thank you guys. Okay, so everyone has understood it. Now let's move on. Okay, so now basically there are a few features of HDFS which are very important to understand. Okay, and there may be some reiteration here, but it's very important, so I'll repeat it if required. So number one, it should be highly fault tolerant. Okay, and it is built in the system. I mean, see, we've talked about using a lot of data nodes to store data. So basically, there's a good chance that some of these nodes can become faulty over a period of time or at any point of time. So the system, the distributed file system, HDFS, should itself have a mechanism to make sure that it is highly fault tolerant. Okay. For that, what we do is we replicate data on multiple machines. So a single data block is not stored in a single machine, but it is stored in a minimum of 3 machines. We will know more about it, but that's the way Hadoop makes the system fault tolerant. Is that clear? So by replicating the data, okay, in multiple data nodes, and not by using very high quality machines, high availability machines. Okay, is that clear to everyone? First point, quickly, can you give me a smiley or a yes? Okay. The second point is high throughput. High throughput is something which is very clear because we've just seen an example that if I use a DFS, then I can reduce the amount of time it takes to read the data by 1/10 if I have 10 node cluster. If I have a 100 node cluster, I can reduce the time by 100 times approximately, not exactly. And if Yahoo uses something like a 5,000 node cluster, so you can imagine how fast the throughput can be by using this simple mechanism of distributing the data across different clusters. Is that clear? How does it achieve high throughput? Okay, great. So then Okay, Sandeep says no. So Sandeep, throughput is the amount of time it takes to read the data. Okay, and by putting data across in parallel and reading it in parallel, you are actually decreasing the total time it takes to read that data. As we saw in that other example of where we were reading 1 TB data from multiple machines. Is that clear, Sandeep? Yes, yes, Sandeep. Gaurav, don't worry about data replication. I will cover that very soon. Okay. Yes, we are gaining the throughput. Right, right, right. Divide the data and get throughput. Right. But it's not all that simple. But it will. There are a lot of complexities involved, and we'll look at that. Now, Gaurav has asked me a question. Replication causes data redundancy. Then why is that pursued? Okay. So the question is that I said, right, to make it highly fault tolerant, we replicate the data in multiple places. So yes, it causes data redundancy, and it is pursued because these computers, as I told you, are commodity hardware. The places where we store data are commodity hardware. They're not high quality, high availability machines. So there's a good chance that they'll keep on failing in between. You can, I mean, the Hadoop cluster can use your and my machine as well. Okay, you don't need high quality hardware there. So that is why we do it, to make it high availability, we replicate the data in multiple places. And we will look at that once again as we move forward. Okay, is that fine, Gaurav? Is that okay to everyone? That why do we use data replication? Quickly, can you give me a smiley if it is clear? Great. Okay, great. Thank you, guys. Thank you very much. So, and as I told you, it is suitable for large data sets. Okay, so it's not suitable for applications which have small files. Okay, so even so basically since a lot of information is stored as metadata on the name node, I'll not get into more into it. It makes a lot of sense if we are storing this data, storing large amounts of data and not small large amount of files. Instead of using large amount of files storing small amount of data, it makes more sense when we have large sizes of files and less number of files. Is that clear? If the data set is large, then it makes more sense, HDFS. Okay, each file is huge. Okay, right. And you'll understand this very soon. Okay. So Anand is asking me to repeat. Anand, I was saying HDFS is more suitable for cases where you have huge amount of data in a single file as compared to small amount of data spread across multiple files. Okay. Is that clear? And the next point is streaming access to file system data, which means that it should have streaming access to file system data. Means that if we are doing something like a write once and read many times kind of operation, which will be the case when we are analyzing logs. Okay, so unstructured data, this will be the case. You will be doing streaming access to data where you will not be updating the records again and again. That's very much different from a bank record. So that is where this makes more sense, where you write once and read many times. Okay, and HDFS can be built out of commodity hardware, which means without using any high-end servers, you can build the high-end storage devices. You can build HDFS. Is that fine with everyone? Are all these points clear to everyone? If nothing is clear, please ask me. It's important. Okay. And otherwise, please give me a yes, or I'll just move ahead. Okay. Thank you, guys. Thank you. Commodity includes, yes, it does. It does include RAM because it has to run a few things there. We'll talk about that. Okay. So Anand is asking me a question. Does commodity hardware include RAM as well? Yes, Anand, it does. It does include RAM as well, and the reason why it needs RAM because there will be some services which will be running on it. The task tracker which we talked about is something which runs on the commodity hardware itself. Okay, we'll know more about it. Okay, Samir is asking streaming access, please explain again. So Samir, in cases where you're writing once and reading the data in one shot, where reading the complete amount of data is more important, the time taken to read the complete data is more important than the time to actually fetch a single record from the data. That is what streaming access is. Okay, like a YouTube video, if you want to, it's not important that you seek a particular point in that video. More important is how soon can you get the complete video buffered. Okay, so and similarly the Facebook logs, you don't need to look at a particular what a person liked in that. Okay, you need to analyze the complete data together. So that is where where you write once and read out multiple times is what streaming access is. Is that clear to everyone? Is that clear, Samir? Okay, great. So let's move on. I've written one more definition. I promised, I broke my promise. I'll keep breaking my promises. So okay, so HDFS is file system designed for storing very large files. One, very important. With streaming data access patterns, that's also very important. And it runs on commodity hardware. So these are the two. Okay, Anand Kumara says promise is always to break. Thank you, Anand. Thank you for supporting me in this. Okay, so basically three important points here: very large files, streaming data access, and commodity hardware. These are the three salient points which you have to look at when you design a Hadoop distributed file system. Okay, if you have to take a decision whether you should move to Hadoop or not, these are the things which you should look at. So people from the architecture kind of background, or who are business analysts, if they have to talk to their clients, these are important things. When the client asks them, why not we also move to big data and Hadoop, you have to answer, you have to look at these points. Is that clear to everyone? I believe Devashish was from that background, right, Devashish? So you might have to answer such questions. So files should be in terabytes. Okay, great. The file should be in terabytes. Okay, great. So Anupam, you had given me your introduction, which I missed. I believe you are an architect. Is that correct, Anupam? Can you quickly tell me yes or no? Okay. Yeah. So people, no. I'm sorry, Anupam. Can you please introduce me to yourself once again? What do you do? Okay, while you write, I'll explain. So people who are going to take these decisions in their organizations, or are going to talk to clients on these, where a lot of clients, because of the hype around Hadoop, they will be asking why we should also move to big data. Okay, okay, okay. You are a ETL developer. Okay, great. So, okay. So you work with TCS with 6 years of experience. Great. Great. So yeah, for you probably Pig and Hive will make more sense, which is fine. And yeah, so basically for people who are into this decision making, whether we should move to Hadoop or not, whether we are ready to take this big data, these are the things which you should look at. Okay, is that fine? Rohit is a solution architect, and Rohit says, I'm a solution architect, and these definitions will really help me as I have to read between lines and explain our customers. So you keep breaking your promises. Yes, yeah. Thank you, Rohit. Thank you, Rohit, that I could actually help you in talking to your customers. Thank you very much. So yeah, very important point, very important definition. Some definitions I'll keep here, and unless and until I believe that definitions are not important, I'll not keep them. But in this case, it's very important. Okay. So even if you're not a solution architect, even if you're a developer, it is very important to understand the bigger picture. Okay, and otherwise you will just be doing some what I should say, bull's job, not donkey's job. Okay. Okay, so let's move ahead. Can I get a quick smiley from everyone if you guys want me to move ahead? Okay, and then I'll tell you where HDFS is not a good fit today. Again, Rohit, Mohan, please pay attention here. Ajay, all the people who are looking at telling people to implement Hadoop, please make sure that, okay, yes, thanks Anand. Anand, okay, so where you have low latency data access, which means that you have to quickly read a record for a bank kind of transaction kind of thing, please don't move to HDFS even if you have huge amount of data. Okay, fine. Lots of small files again, because the file information is stored in as metadata, and if you are, yeah, I'm telling you that, Sandeep. Just give me 1 second. Okay, because if you store these, see, Sandeep is asking me why. Okay, and I'll answer this question as before we move on out of this. Okay, and when I say where HDFS is not a good fit, I also add something called today. So going forward, Hadoop is working on it. It might become possible to do all these things also as efficiently as a traditional database can do. But as of today, Hadoop is used for reading out huge data sets in one single shot. Okay, if you want to seek a record from a file, this probably is not the best way of doing it. Okay, because you will not know where a single record is kept. The information is kept at a very, very high level in terms of blocks, and data is usually unstructured. There are no tables and columns. The data is stored as multiple logs. Okay, and if you have a lot of small files, then also this doesn't make sense, because for each file you will have to store a metadata, which will make things very difficult to seek whenever you want to. Is that clear? Is that clear to everyone? Okay, and the most important point is that if you're writing data multiple times and if you're doing arbitrary file modifications, HDFS is not a good fit. Okay, which means that if you're updating the data again and again, the same row, same column again and again, then HDFS is not the right place to do it. A traditional RDMS works better. Okay, so see, Rohit is asking me a question. If not Hadoop, then which tool is a good fit today? Any recommendations? So guys from the Teradata and Oracle background, can you boast about that now? Can Syed answer that? Sandeep, just give me a second. Syed, would you like to answer that question? Yes, RDBMS will be used for this, right? So Sandeep, the question is low latency data access means that if you have to quickly seek one particular data from a file, okay, then this is not the best thing. Hadoop is better when you have to reach the complete file in one shot and then do analysis over it later on. Okay. Okay. Now there are frameworks which are available on top of Hadoop. As Pig actually is something which can do some SQL-like operations. Hive is the place where you will be doing a lot of analytics there. We will talk about those as we move forward in the course. Okay, fine. So Sandeep, is your question answered? See, I'll not get into details of any of these things right now because not everyone would be interested in it right now, number one, and not everyone will be able to understand it also. So please be patient with me, and some answers I'll give you later on. Okay. As we move, I mean, I can ensure if you attend all the 8 classes, you will understand everything. But today also you'll understand HDFS. So can I move forward, guys? If this is clear to everyone? Okay, I'm getting a lot of yeses. Great. So now we talked about name nodes and data nodes. Now it's time to remember what I told you in that slide where I told you just remember something. Okay. So there was something associated with a name node. Can you quickly answer that on the chat window? What was associated with a name node? I'm getting some answers. Okay. 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 Sandeep, I did not tell you that. Okay. So everyone has given me the answer, which is job tracker. Okay. Yes. So job tracker is the thing which is associated with name node. Okay. Yeah. And data nodes, what was that with data nodes? Task tracker. Correct, correct, correct. So basically there are two major components of HDFS. One is the name node and the other one is the data node. Name node is the master node, okay, on which the job tracker runs. Okay, job tracker is a daemon, right, which runs on the name node, and data node is again that commodity hardware on which another daemon called task tracker runs. Okay, so now I'm introducing these two terms in slightly more technical language, but going forward in the next couple of slides we'll understand more details about it. Okay, is that fine with everyone? So major components on HDFS is name nodes and task tracker and job tracker and data node and task tracker. Okay. Okay, Samir is asking what is a daemon. Can anyone answer that question? What is a daemon quickly? Okay, Rahul wants to answer that question. Rahul is with me. Rahul, you want to answer that question?
Hi everyone, this is Rahul. Samir, to answer your question, what is a daemon? Yes, it's basically a process or a service that runs in background. It's very well said, Mohan. It's a resident program. It's a resident program, and it is a service that runs in the background. You can call it a process also. Okay, so that is what a daemon is, and is used in the Unix environment. This terminology is used in the Unix environment in general. Does that answer your question, Samir? Mohan says the equivalent in Windows is a service. Yes, Mohan, it is a service in Windows. And in DOS is a TSR. Yes, definitely. That's a definite yes. It's a TSR. So I'm handing it over to Abhishek now again.
Yeah, so thanks Mohan for the insight. So Mohan has told us more about daemon. So Mohan says that yes, they run in background, Samir. Yeah. So Mohan has given us some very good information. Mohan tells us in Windows, the equivalent of a daemon is a service, and in DOS it's called TSR. Okay. So can we move ahead, guys? Okay. Yes, Samir. Yes. Okay. Guys, I'm really sorry I grabbed a couple of chips in between while I handed over the mic to Rahul. So if you're hearing some crunching noise, I'm really sorry for that. So Mohan is okay. Mohan has given me one more thing. Mohan is saying I am proud that I am going to be the only ex-DOS programmer here. I am the only one. There won't be anyone. Okay, there won't be anyone else who is a DOS programmer. Anyone else who is a DOS programmer here? Mohan, I have done something in school. Okay, but I'm sure I've not done anything as much as you would have done in your days. So Mohan is an ex-DOS programmer, and is there anyone else who has done programming in DOS? Syed Munawwar is again saying I've done it. So Mohan, you're not alone in school. Okay. Hey Mohan, thank you very much. Mohan says I've written the first version of Norton antivirus in DOS and Windows. So Mohan, really great to have you here. I'm sure we'll learn a lot from you, sir. So Mohan is the guy who has authored the first version of Norton antivirus in DOS and Windows. Great to hear that. Can everyone give me a smiley or a clap for that, guys? Wow, Syed says wow. Great clap, says Gaurav. Awesome, Mohan, says Rohit Malik. Okay, with claps, Yashwant. Ajay has given smile. A big applause from Anupam. Mohan rocks, says Rahul Tiwari. Clap for Mohan Anand Kumaran. Okay, great, guys. So thank you very much, everyone, for appreciating Mohan's effort on antivirus. Otherwise, we would be right now. Maybe some virus would have been injected in this system itself, and we would be. We would have gone for a toss. I could not crack a joke here. I'm really sorry, guys. Not every time I'll be able to do that. Okay. Mohan says it's ancient. Mohan, you're young. Okay. So main components of HDFS. Okay. Now we have. I've put a picture here. Can everyone identify with this one? And can anyone tell me if anyone has ridden this vehicle anytime? Mohan, I'm sure you must have been. You looks like you must be having really deep pockets with all those authoring, and you've exited from your company as well. Okay, so everyone this is their dream car. Mohan, have you ever taken a ride in this one? Oh, Rahul Tiwari has taken it. Great, Rahul. Where did you get a chance to do that? This car, Mohan, can you identify this one? Samir has also done it. Samir, Sweden. Okay, great. So this is a Lamborghini. Okay. Sandeep tells me I also have taken this in dream. So with whom did you dream this, Samir? So sorry, Sandeep. Katrina Kaif? Oh, yeah, tasks were covering, but okay. Sandeep says my wife. Okay. Sure, Sandeep. In your dreams, okay, that's really good, man. Really loyal husband. Your wife will be happy to hear that in your dreams you dream about her, and that too in a Lamborghini. Okay, so Mohan, did you take a ride in this one? Okay, Gaurav says Sandeep is a liar. So it's getting great here. We have got a great environment here. Okay, Mohan says not wealthy enough. Okay. So Gaurav says Sandeep is a liar. Okay, I kind of agree with Sandeep, with Gaurav or with Sandeep, I don't know. And Samir is giving me a smiley. Okay. So now the reason, let's get a little serious here. The reason I put it here is that this is the name node, and the idea behind putting this car here is that you need to understand that we have to put a very, very reliable hardware here, double, triple redundancy hardware. Okay, high reliability machine. You might end up putting a RAID here. Okay. So name node is the master of the system. It maintains and manages the blocks which are present on the data node. Okay, please note that it doesn't store any data. It maintains and manages the blocks which are present on data nodes. So it is the data nodes which actually keep the data. Okay, is that clear to everyone? And the reason why I put a Lamborghini here, it will be a very, very expensive hardware and it will have a double and triple redundancy there. Okay, is that clear? Okay, now can anyone identify this picture? Sandeep, have you taken a ride in this one in your dreams? Kolkata taxis. No, Sandeep doesn't dream about ambassador. Okay, so these are ambassadors. Our politicians and all our government officials take rides in this, not in this colored one. Gaurav says reality check. Okay, yeah. So Anand Kumaran says old taxis in Mumbai. Yes, Anand, I don't know if you said Mumbai. I just added Mumbai. Oh, so Vidyasagar told me, oh boy, I thought you would go with the Nano. Okay, Sayyid tells me still in Kolkata, these are the taxis which are run. No, I actually Ambassador is much more expensive than a Nano, but I still would like to take this analogy to tell you why I said commodity hardware. Okay, so a name node is like a Lamborghini and the data nodes are like ambassadors. Okay, did you like this analogy? Do you want to praise me on this? Okay, so don't praise me. It was put by Hisham, who is the guy who is in the support team. I just take the credit. But
welcome to GoToWebinar, web events made easy.
guys, are you able to hear me now? Okay, I'm really sorry. What happened was that I got so excited that I pulled the microphone out of the computer. I'm really sorry about that. Okay, so yeah, I was telling you about that. It was Hisham who actually did this. I'm sorry for the interruption, but yeah, it was Hisham actually who put this analogy, and the reason I'm calling this name again and again is because he's the guy who leads the support team here. And for any queries on which you might have on any practical issues 24/7, he is the guy to catch. Okay, so he and his team will be supporting you, and these guys are experts in this course and Hadoop, and they'll be able to help you with any problem you face. So feel free to reach out to Hisham after this class for any questions. Okay, is that fine? Is that okay? Everyone is able to hear me, guys? Now back. Am I back with you? I did not get any response. Okay, great. So sorry for that. Okay. Now data nodes are, we say, when we talk about data nodes, these are slaves, as I said earlier, deployed on each machine and provide actually the actual storage happens on data nodes and not on name nodes. Okay. And these are responsible for serving read and write requests for the clients. Okay. So the read and write actually directly happen from data node. Now don't worry about that. I've just said something. That read and write happen directly from the client. I'll explain that in detail as we move forward. Okay, just keep this thought in your mind. Okay, is that fine, guys? Can I move ahead? Yes, Mohan. The task tracker runs on each data node. Okay, great. We'll understand all this. I'll ask you questions in the end of the class, and I'm sure all of you will be able to answer that. Okay, Sandeep is asking me a question. If data node increases, then do we need to upgrade name node? Sandeep, at the beginning of when we define the system, we see that, okay, till what level do you want to scale up your cluster? Based on that, we choose a name node. Most of the times, yes, you do not have to upgrade your name node if you increase the number of data nodes, because name node does not store much information. It is just RAM, and it stores mostly the metadata. I'll make you understand more about this. Anand is asking me a question which is an interesting one. He says 2 servers are required for name node, data node. Well, ideally in the real world, there will be a name node which will be on a high availability software hard machine like a Lamborghini, and data node will be like ambassadors. But if you want to try out something, then a same machine can be used to create one data node and one name node. Okay, it can run on the same machine. Okay, now Mohan has asked me a question, is the name node also commodity? No, Mohan, that was the whole point in actually putting this Lamborghini picture here. Name node has to be a double, triple redundant machine, which can be even a RAID. Okay, so it cannot be a commodity hardware, because this is the single point of failure in the system. And when I say as single point of failure, I'll explain it. So don't worry about it right now. Okay, we'll understand. Mohan, does that answer your question? Can I move ahead? Okay, great. Data node can be redundant. Okay, now let's go a little deep. Mohan, we'll answer these questions as we move ahead. Okay, is that fine? Okay, as we move ahead, we see we've introduced a new term here. Can everyone look at this diagram for 10 seconds, take a deep breath, and think about what? Sandeep can think about his wife, and I'll think about Katrina Kaif. Okay, and look at this, and client, job tracker, task tracker, map, reduce. What is the new term here? A client, right? Anything else which you see as a new term on this slide? Do you understand everything else other than the client? Everything else we've covered? Okay, MapReduce, yes. We've talked about MapReduce earlier as well. We've said MapReduce is a programming model to retrieve and analyze data. Only this much has to be understood today. Okay, it's a simple programming model. Okay, is that fine? So other than the client, everything else is clear to everyone? Okay, cool. So client is actually client is an application which you will use to. I'm giving the answer. A client is an application which you use to interact with both the name node and the data node. Okay, which means to interact with job tracker and task tracker. Is that fine? Is that fine? As a very simplistic definition, a client is an application which will be running on your machine, which you will use to interact or give commands or look at the statuses from a job tracker or a task tracker. Is that correct? Is that okay? So interaction between the user and the name node and data node is done through a client. Okay, and it is called the HDFS client. Is that fine, everyone? Can you quickly give me a smiley on this? Or else I'll move ahead. Okay, cool. Okay, let's get. Okay, Sandeep is asking me a question which I'll answer. Sandeep will get an answer, don't worry. Okay, Devashish, client is a application or a software which will run on your machine. Okay, we will see an example. We'll show you how a client looks like by the end of this. Okay, client is an application which runs on your machine. Okay, which you will use to interact with data node or a name node, which in turn means the job tracker or a task tracker. Okay, we will all your questions will be answered, Anand, and Sandeep, your question will also be answered. Don't worry, just keep that in your mind. Just keep these questions in your mind. All these questions will be answered. Okay, so let me just Rohit, I'll answer your question as well. Just give me 1 second. Okay, now let's look at this diagram. This is a little more complex than the earlier diagrams. A few more new terms are also introduced in this. Okay, and I'm going to explain this. Don't worry, you will by the end of this slide you will understand each and every term here. Okay. So we have a name node here which is clear to everyone. We have a client also which we've understood. We've understood that as well. And now there is something called a rack. Can anyone explain me what a rack is? A lot of people will be knowing that. Is there anyone who doesn't know what a rack is? Okay, Sandeep tells me it holds hard disks, right? Gaurav asked me to tell you. Okay, Ajay is asking me what a rack is. Okay, can anyone give me a? Okay, Anand is telling me rack is a storage area, which is right. Can anyone else add to that? Devashish tells me the storage mechanism. Can anyone else add to that? Okay, okay, there are more people. Okay, so yes, we have some answers here. Samir Mahapatra tells us that it is a group of nodes. Yes, it is, that's right. Data stores in clusters, in a cluster, right? Yes, Gaurav, collection of data nodes in a cluster is, so a rack is I believe Syed will be the best person to answer this question. Syed, can you answer this question quickly? Can you give me an answer and tell me if you're with me? Looks, sorry. Okay, so basically rack is a storage area where you will have multiple data nodes put together. Physically, we said that all these data nodes can be physically at different places, right? You remember the first diagram when we showed you 4 different machines at different physical locations? Do you remember that? And then we created a DFS out of it. So basically a rack is a physical collection of data nodes, okay, which are stored at a single location. Okay, so basically there can be data nodes stored in Bangalore, there can be data nodes stored in Kolkata, there can be data nodes stored in Australia. Together we can have a set of data nodes can be stored in a physical location in a rack. There can be multiple racks also in a single location. So it doesn't mean that if it is stored in a single physical location, it will be stored in a single area. Is that clear to everyone now? Rack is just like a rack. You have a rack of shoes, right? Where you store all your shoes. Similarly, we have a rack of storage devices. Is that clear to everyone? Can I quickly get a smiley here from everyone who said no then? Okay, cool. Everyone has understood that. Great. Then, so what we're showing here is, Ajay, thank you very much. So what we're showing here is that we have a name node. We have a client which interacts with the name node. And Rohit, I'll quickly answer your question here. Rohit had asked me what is the mode of communication. Is it HTTP? HTTP? No, it is SSH. Okay, we'll answer. Rohit, is that clear now? So Rohit had asked me a question that how does client interact with name node or data node? Is it through HTTP? So Rohit, it is through SSH. Okay, and for everyone else also, this is the answer. Now we also see a term called replication here. Okay, so as I told you earlier, data is always to maintain the fault tolerance on a Hadoop system. Okay, to maintain fault tolerance on a Hadoop system, we replicate data. We maintain multiple copies of the same data on multiple data nodes. We'll understand how it is done. In very clearly, we'll understand minimum number of replicas should be 3. That is the minimum number of replicas required by HDFS. Okay, and it can be defined by the user. Okay, so basically when you write a data on a HDFS, you replicate it in at least 3 data nodes. Is that clear? Okay, is that clear to everyone? Okay, great. Then there is something called block ops. Okay, so basically the operations are performed in terms of blocks. Okay, now the block size Rahul, you have to, Hadoop advises you to at least, Rahul is asking, is it compulsory if I didn't want? See, as I told you, right, we use commodity hardware here and we still don't want to lose data, and there is a good chance that some of these machines will keep on failing. So we need to keep data in multiple places. Okay, the redundancy has to be maintained, replication has to be done. Okay, okay, is that fine, Rahul? Okay, now, okay, now the other thing which I was telling you was that the block size in HDFS is, can someone tell me other than Mohan what is the block size in Unix? Can someone tell me that? What one quantum of block, how big is that? No one knows about it? No one has answered that question. I'll let Mohan answer that. Mohan, can you please tell me? What is the block size in Unix or a Linux machine? Guys, you can do Google as well. I'm not your teacher. I'll not stop you from doing Google. Please Google things which you do not understand in the class, which you want to ask actually. Okay. Okay, no problem. And can you guys Google? Don't think that I am the only source of information. You can also be the source of information. Google is the biggest source of information. I have also learned everything from Google. Can someone give me that answer quickly? Rahul Tiwari, where are you, man? And where is our friend Devashish? I have not heard from a couple of guys for a long time. I want them to answer now. I haven't heard from Dinesh. I am asking the default size. So Ajay is giving me an answer 8192 bytes. Pawan, you've not answered anything, friend. Can you quickly Google this and give me an answer? You can keep this answer for yourself. I'll tell you. Okay, so we've got a lot of people giving me the right answer. Okay, so now the block size in HDFS is 64 MB. Okay, it's 64 MB, and the default block size in Linux is 8192 bytes. Okay, so basically HDFS is built over Unix, and HDFS, as I told you earlier also, is used to store huge amount of data, the single block of operation. And I'm asking about the default size. It can be configured to a bigger size. The minimum is 64 MB. Okay, does that make sense? And this clearly tells me if you have smaller file sizes, there will be a lot of metadata which you'll have to store, and it will not be a very useful system to use. Is that clear to everyone? Usually it will be much more than 64 MB. We'll be configuring it in a few GBs or maybe sometime TBs. Is that fine? Does this answer that question which everyone had, that why can't we store many small files in HDFS? Is that okay, guys? Okay, good. So everyone has understood that. I've got a few yeses. I did not get a response from Pawan. Pawan, can you quickly answer this if you have understood this? Thank you, Pawan. Thank you very much. I think you were out for lunch for some time. Is that correct, or you were here? You were attending everything. Guys, I'll be asking questions in the end, and everyone will have to score 100 on 100, okay, 10 on 10. So please pay attention. Now, okay, so we've understood most of these things here. Now I'll just explain this diagram once again. So we have a client which interacts with a name node. It also interacts with the data nodes, okay. The client does a read and write. There's something called metadata here. So can anyone tell me what is the metadata? Quickly, can someone tell me what is the metadata? Okay, so a lot of people have told me the right answer. It is a configuration data, data about data, data into data. Yes, that's true. So metadata is not the actual data, the actual logs which will be storing, but the data about data, which means where are these. If I'm storing a block, name node will have this information that where is this block where is this data getting stored. Okay, that information, which are the name nodes, where are the racks there, on which rack which data node is there. All this information, block map is what, yes, exactly. So a block map is what Mohan has told me. This is exactly correct. So all this is metadata, and all this data is stored in the name node. Name node, this data is stored in the RAM. Please remember this. It's stored in the RAM. I'll tell you more about it, but for now, let's understand that it's stored in the RAM to have fast access. Okay, and actual data is stored in the data nodes. Okay, so is that clear to everyone? We will go into more details of these operations, read and write, as we move ahead. But for now, does everyone understand what a name node is, what metadata is, what replication is, why do we need replication, what data nodes is, what a client is, what a rack is? All these, if the answer to all these questions is yes, please quickly give me a smiley. If you don't understand anything, please put that name there. I'll explain it again. Looks like everyone has understood. I'm doing a great job. Okay, Samir is asking me what about block operations. Samir, I'll answer that going forward. Okay, don't worry. So each time name node create metadata when we are on cluster. Sandeep, can you rephrase your question? So name node is a high availability machine, a Lamborghini, which will be stored anywhere. It should have good protection. Yes, it will be, okay. So Sandeep has a question. Yes, all this metadata is stored in a RAM. There's something called a secondary name node, and I am introducing a new term here, so please pay attention. There's something called a secondary name node, which is used to, which periodically reads the data from the RAM of the name node and persists that data into a hard disk. So name node does not write it into a hard disk. Name node keeps that data in the RAM. It does not spend time or operations or cycles in writing into the hard disk. There's something called a secondary name node which keeps on reading from the name node, okay, data from the RAM of the name node and writes into the hard disk. Okay, is that clear to everyone? But secondary name node is not a substitute of a name node. Okay, so if the name node fails, the system goes down, and that is the case in Gen 1 Hadoop. I'll tell you what happens in the Gen 2 Hadoop, but for now, let's try to understand that name node is a single point of failure. There's no backup name node, which though it is called a secondary name node, it does not become an active name node if the name node goes down. It just reads the data from the metadata from the RAM of the name node periodically and keeps on writing into a file system. Is that clear to everyone? It does not come into picture if it keeps a backup of metadata. Okay, so it does not if the name node fails, it does not become the name node. Is that fine? So in Gen 1 Hadoop, when we talk about Gen 1 Hadoop, there is just a single point of failure, which is name node. If the name node fails, the system crashes. Okay, and to get the system back, you'll have to put another name node and read the data back from the secondary name node, and you cannot retrieve the data from the time the last backup was taken. Is that fine to everyone? That is why we need a Lamborghini for a name node. Does that make sense to everyone? Is there anything which is not clear here, guys? Okay, good. So everyone has understood why we needed a Lamborghini there? Because we do not have any backup to it. Sandeep, just give me some time. I'll explain everything. I'll explain everything. Okay, just give me some time. All these things are going to be covered in the next slides. Okay, yeah. So basically, the important thing to understand here is that the name node stores all the data in its RAM. There is a secondary name node which keeps on reading this data from the RAM and keeps on writing into a file system. It is not a data node, it's a separate file system where it keeps on writing, Rahul. Okay, so to make sure that we are storing what was happening in the RAM, and it keeps on syncing that data time and again with what is there in the RAM of the name node. Is that clear to everyone, guys? Very important concept. And if you guys are preparing for an interview, someone can ask you what happens if the name node crashes. Does the secondary name node take over? The answer to that is what? Yes or no? Very good. Everyone will crack that interview for Hadoop. Vidyasagar, tell me definitely not. Rahul, you will move from Teradata to Hadoop, man. Okay, so that's a very important thing. Now, okay, now the second thing which is very important is, and I'll take a liberty to introduce that as well. I talked about Gen 1 Hadoop. So now there was this problem with Gen 1 Hadoop that we had just saying a single point of failure, and the secondary name node was a misnomer. It's actually a misnomer. It looks like that the secondary name node, and it's actually used to fool people in interviews. Okay, so it's a misnomer. In Gen 2 Hadoop, now someone can ask you this question as well. Now, what is the difference between Gen 1 and Gen 2 Hadoop in terms of name node? So in Gen 2 Hadoop, we have an active passive kind of name node structure where there are two name nodes. One is the active one. There is a second one which is passive one. Very important to understand. Pawan, are you getting this point, sir? Anyone preparing for interviews? I was told that Pawan is preparing for some interview. So it's very important to understand this. So in a Gen 2 Hadoop, we have okay, great. Sure, Rohit. Okay, so in Gen 2 Hadoop, we have an active passive kind of a structure where there is an active name node and a passive name node. So in that case, if the active name node goes for a toss, the passive name node can take care. So that is the difference between Gen 1 and Gen 2 Hadoop. Is that clear to everyone, guys? I'll ask these questions in the next class as well. So you have to remember this. Okay, good. Yeah, it's a standby kind of thing. Right? Yeah, right, Rahul. Okay, Ajay says, okay, can everyone give me a smiley if you liked this idea? If you really liked this, Good. So there will be a secondary name node which will keep on doing a backup data. Okay, but active name nodes will just store data on the RAM. Okay, Sandeep. Name nodes will not waste their cycles. Yes, name nodes will not waste their cycles in writing data to the file system. Okay, name node are high availability machines. They are very fast, very expensive. We will not use a Lamborghini to drop you to the mall. Okay, is that fine, or to pick you from the railway station? Okay, let the secondary name node do that. Is that fine? Rahul, we'll talk about it later on here. Don't worry. Okay. Yes, there is a secondary name node in J2 Hadoop as well. It will be there because we have to store all this data persistently. We have to persist all this data in the hard disk. Okay. So let's move forward, guys, if everything is clear here. Okay. So now we'll get into a little more details. Okay, so where is MapReduce used? Okay, so we have a lot of data from the weather forecasting. Okay, where we have a lot of climate data, which is, say, from since the beginning of the century. We need to analyze what will the maximum temperatures. We'll do a lot of predictions based on that. So that's one place where we'll be using MapReduce. Can you tell me where in healthcare will we be using? Okay, patient reports, auditing, product distribution, right, claim processing, right, ECG monitoring, machine data flowing in the tools, says Vamsi, right, identifying fraudulent claims, okay, DNA research, Sachi, right, that's true, scanning data. So yeah, so there are a lot of applications. We have a lot of unstructured data from all these industries, and these are not the only industries. There will be a lot of other industries where, say, utilities side, oil and gas industries, right, we'll have a lot of data which we need to analyze, and we'll see how we used to do that earlier. Okay, now okay, so we'll just see how we used to do earlier, and then we'll see what are the challenges there in the earlier methods, and then we'll see how Hadoop and MapReduce solve that problem. Okay, so let's look at one of these examples. Now what I've done is I picked some data from this site, NCDC. This is climate data. Okay, and so this has, for each of the years, right, it has the data here. Okay, let me show you some of this data, how this data looks like. Okay, so that was on the PPT. Now let's see this data. Let's see where I got this data, and we'll see what do we do with this data. Okay, so let's look at year 2013. Okay, Rahul, are you able to hear me now? I mean, I think there may be something wrong at your end as well, because everyone else says that I'm audible. Okay. So this is one data set, huge data set. So there'll be such data sets, and I've just picked up one from that file. There'll be terabytes of such data. Now look at this data. It's like a log data. Lot of columns are there, and it is delimited by space and tab. Okay. So you don't have to worry too much about what are all the fields here. The whole idea is to present it to you. Yeah. So if you want to see what all is there, let's see what is there in this data. Okay. Yes, it is. It is. That's right, Ashish. Okay. So now it says that WBAN number is something which we do not care too much about. Then there is this local standard time, which is from column 7 to 14. We have columns longitude, latitude, daily max temperature, daily min temperature, daily mean temperature. So lot of such data is there here. Okay. Now what we want to do probably with this is that in this, if I have to say find what in every year, right, what is the maximum temperature which occurred, or how many days can be classified as hot days, how many days can be classified as cold days, right? So can anyone tell me how will you find it if this I mean, forget about Hadoop, right? How will you actually find it out? So if I have to tell you that for each year, give me tell me what will be your traditional way of finding it out? How will you do that? Yeah, the columns are fixed, Vamsi, right? That's true. Okay, so Sachi is telling you we'll load data in Oracle and SQL it. Okay, go through in row and column value, max function, right Vinay, okay, and evaluate for a range, okay, okay. Is anyone from the Unix background here? Yeah, great. So Ravi has given me some answer there. Very good. So Arka has given me a very good answer. Okay, put it in a file using awk. Very nice. So that's what Rajat has also given me the same answer, awk. So how many people know about awk AWK? Everyone knows about awk? Yeah, Avinash, you can write a script in Perl as well. Great. Okay. Okay. So don't worry, whoever does not know about awk, okay, that's not really required in this course. But what I want you guys to do actually is, I'll send you some code in awk as well. So what we'll probably do, see the whole idea, no problem. Even if you're from the mainframe background or any background, doesn't make much difference. Okay, so it is very simple. So in Unix, if I have to take this file in, what do I have to do? You see, the fundamental thing will be that for each record, right? For each of this record, which has one record which has, say, this is the maximum, this is the minimum temperature. I have to loop through this record, okay, and figure out if put this into a max temperature thing and see if as I go further, whenever a max comes in, you know how to write a program to get this done, right? So awk or Perl, or these are scripts, scripting languages which can be used for record-oriented data, which can quickly do those things, right? So awk will be the fastest, Perl will be slightly slower, but it will be again very good for this kind of thing. You can do this in Python as well. Okay, so does everyone understand what we're talking about here? Is there anyone who has no clue? I know a lot of people have understood, but anyone who has no clue can tell me. Okay, everyone, most of the people have understood. So now if I have to figure out, okay, Amrish is saying he has not understood. So okay, Amrish, let me make it very simple for you. Okay, so now this data has a lot of records, right? Each line is a record. Now each line, this column is one value, then this column is another value, this column is another value. This column probably is the date, okay. This column is the maximum temperature, this column is the minimum temperature on that date, okay. And if I have to figure out that what I'll probably do is all the remaining I don't care about, because I just need to look at what is the maximum, the minimum temperature on a particular date, right, or on a particular year, right? That's what I'm looking at only. Okay, so if I have to look at that, all the other columns I can ignore. I can just look at these columns from each record and then do some processing to figure out whether it is the maximum temperature in that year or not. Right? Is it making sense at a theoretical level? Is it making sense? I'll show you how to do that. Great. Okay. So yeah, so everyone has that idea. Good. Good, Ravi. Thank you very much. Okay. Now, what I also want all of you guys to do when you go back home is to look at how does awk work. It's a simple language, okay, very, very simple language, but though you may not be required to do that, but it's always a good skill to have. When you're working with data, learning awk and a little bit of Unix is very, very, very handy, right? And I'm sure my friends Ravi and other people who have worked on Unix, or maybe Dilip is a Linux administrator, I believe. Dilip, you are comfortable with awk? Can I quickly get that answer? Great. So what I want you guys, whoever is comfortable with awk, is to write a program in awk. Arka, don't worry about those values. Okay, you don't have to worry about all the values which are there in the record. I also don't know. We just need to pick up some values. You can read this README file to figure out what all does this contain. Okay. For now, let's concentrate on these three values. Okay. Now, whoever knows awk, I want them to write a program in awk, okay, and send it across as an assignment, okay, to us, in which we will give you one of these files, and you have to use awk to write the same thing which you're going to do in Java today. Okay, is that fine? Everyone who knows awk, can you quickly give me a yes? Great. And we will be sharing that with everyone else in the class. Okay. So I want you to write this by tomorrow if possible. Whoever gives me the first answer, Dilip and everyone, whoever gives me the first answer gets some bonus points. Okay. So great, Sachi. So sure. And other people who do not know awk, I want them to Google a little bit on awk, look at this data and try to create a program in awk for doing this work. Okay, to find out the maximum temperature here. Is that fine with everyone, guys? We will be sending out the awk program as well. So by Thursday, I will wait. If I get an answer from everyone, then I will not send anything. Otherwise, I'll write one and I'll send one. Okay, fine. So we will learn with each other then, right? So now coming back to the slide. So this is what we used to do earlier. Yeah, we will be sending you the input files. This data set is available. We'll be sending you the link to that. Okay, so an input file I'll send you. Okay, I'll also, yes, Rajat. So I'll also send you the exact problem statement just after the class. Okay, so don't worry. Okay, now so this is what we used to have, and as you have told me that you could use awk to do this. So then if we could use awk, what is the problem then? Why do we need anything else? When I am so much, I'm a big proponent of awk. I'm a big proponent of Perl as well. So why do we need something else? Amrish, what could be the challenge there? Okay, large number of files is what Vamsi says. So large number of files can be done. Portability is, yeah, data volume with limited data set. Okay, yeah. So basically all those reasons which we had to adopt Hadoop. Okay, so Sachi is telling you market is hot with Hadoop, so sama ke saath chalo. Yeah, that's a good answer, right? But okay, but the fact is that you can do a lot of things with awk. Now the challenges are that, and I'm sure you will yourself figure it out. So what I'll probably ask you to do is write the awk program to run it on a small data set, which is one of these. These are few KB files. Now when it becomes terabytes, right, then the problem is that as we saw right from the first class when I was telling you what is the challenge in the world, not storing data. It is reading it and analyzing it, right? You remember that thing which we showed you in the first class itself, where we showed you the time to read from a single machine versus time to read from a distributed fashion? Everyone remembers that figure? Right, seek time is the problem, right? So that's why awk also, or any such program, will have a problem. So what could be the probable solution for that? Even if we have, so we can split that data, right? So if I had so many files, I could split this data, do a grep, or I mean, I've made it very simple. We did not need to do any awk. We just need, you can do grep also. For the people who do not know grep, please look in. Grep is the command to take out a few regular pattern from in Unix. Okay, so whoever does not know grep, go do a googling on grep as well, right? So if we had, as we saw, right, if we had huge amount of data, what would we do? This is your very big data. Now, one of the files which we saw was this data only. So what I'll probably do is split this data into multiple files, okay, and then do grep on each of these. Whatever matches, do a cat and create a final output, right? All matches can come here, right? So is it making sense? That will be that obviously the next thing which you would think of doing. Is that correct, guys? Anyone who is not with me till now? Just say no. Everyone is with me? Great. Now you have to tell me, the next question I'll ask is, if everyone agrees with this, then what are the challenges in this approach? Can someone throw some light on that? What are the challenges in this approach? The approach is very simple. You have very big data, split it into multiple data sets, run it on different machines. Okay. Splitting the data, okay. Time consuming, it was time consuming, that's why you split it, right? So don't worry, Orca, what pattern? Let's just, yes. So one very good thing which Dipankar has told me is, yeah, reliability is one answer which I've got. Guys, yes, very important thing, reliability. Failover mechanism is what Dipankar is telling me. What else? Is there anything else? Computation is not done, Avinash, at one place. We can compute it at multiple places also. So the solution is simple, right? What I've done is, what I'm saying is, all this, you split this data, put it in different machines and do that thing. Parallel, do it parallelly only. Now I'm not saying that do it in sequence or in single machine. I have agreed that we can do it in parallel. So you have said 1 terabyte of data, okay, split it into say 100 parts, and then do grep on different machines and then do a cat. So this is feasible, right? That's what this is feasible. if I had to do these two operations, this is feasible, right? Great. So now I want to know what are the challenges in this approach. Why do we need something else? Something which has taken the market by storm. So Vamsi, see, Hadoop is also working on Unix only, right? This can be done in other things also, other languages also. Unix is one way of doing it. I mean, similar things will exist in other languages as well, right? Other platforms as well. So that's not really the thing. So why did we, if we could do this here, okay. Okay, so now Rajat has given me one answer. Okay, Tush, okay, great. So Rajat is saying failure on one machine can corrupt the entire matches. Right, so that's one good answer. Okay, it is not robust as Tushar is saying. Tushar is saying the job to split and integrate after CAT is still a manual process. Well, my friends Dilip and Ravi will quickly create a script for that as well. That should not be a big problem. They can do that. But then yeah, I've got very good answers now. I think most of the answers I've already got, right? Orca is saying instead of reading record by record, it will be read block by block. Okay, fine. But finally you will be doing a record. It will be read completely block by block. But when we do a analysis over it, it will still be a record by record analysis, right? And we'll show you that. So that's not really the reason. See, have you ever heard about critical path? Everyone knows what is the critical path in a, okay, some people have, some people have not, right? I'm sure whoever has done a PMP exam, they would have, that is the first thing everyone will know. But you don't need to do PMP for knowing critical path. See, critical path means that, okay, Ravi, yeah, great. Okay. Yeah, yes, Ravi is right. Sachai ko certificate ki zarurat nahi hoti. That's true. So don't need a PMP to know critical path. You can know critical path and still not be a PMP. Okay. But anyways, you don't need any, see, the reason I'm putting this thing here is that one very important thing is that now it will also depend upon the machines which you are using, okay, and their processing capacity of each machine, okay, will be important here when we are splitting this data, right? And if a machine is, one of the machines actually is a smaller processing capacity machine, then that will become the critical path and it will delay the process for everything. Is this making sense to everyone? Say for example, this grep is done very slowly. All these were ready. This took 2 hours more. So everything took 2 hours more, right? Is that, yes. So, right, is that making sense? So that's what critical path is. So anything, now I want Ravi, who is a PMP, to define critical path for me, and I'll read out that definition so that yeah, Ravi, I want you to actually speak if you can, if you have a microphone. Okay. So Ravi is saying I'll not tell. Who's going to define critical path for me? I mean, you have Google as well. Everyone can go to Facebook and look at that. But you have to define. Samrish has gone there. Rahul has gone there. Ramesh, Ranjit, Vamsi, Vinod, all of them have gone there. Other people, Shriram, you already know what a critical path is? You might as well appear for the PMP exam after this class, man. Because you're going to know what a critical, see, how many of you are actually managers? Very good. Rajat has given me the right answer and he's a, okay, Vamsi, don't worry, you can check on your mobile. Okay. So Rajat says I'm PMP certified. Congratulations, Rajat, for that. And it's a good thing to, no, I can't trace mobile phone usage. No, I can't do that. So yeah, so Rajat has given me the definition. Thank you, Rajat. I'll just read it out for everyone. And it's actually a very good definition, a very accurate one. Rajat says it's the amount of time to finish the job without delaying the next milestone or actual completion date. Right? I'll repeat it once. Please pay attention, everyone. And I want everyone to say thank you to Rajat for that. Rajat is saying it is the amount of time time taken to finish the job without delaying the next milestone or actual completion date. Right? So does everyone know what is critical path now? Everyone is saying thanks to you, Rajat. Okay, great. So now, see, this is the beauty of having so many people in the class, because everyone can give us something. So Rajat has yeah, great. So now, as I told you, right, if one of these graphs end up becoming a critical path, see, first thing is, can you really split the data into equal parts? That's one challenge, right? Because you may not be able to split that. Now, if this is yearly information also, it is possible that in some years there were more records, in some years there were lesser records, right? And it is very difficult to actually split that. Does everyone understand that? Does everyone agree with that fact? So, and even if we split them equally, then the next challenge is the critical path problem, right? So two problems we understood. First is splitting in equal proportions may not be the best way to handle this, because sometimes same data which we would have actually easily managed, it was in the same split, would have gone into the next split and it would have led to a problem. I'll show you this example of this later on, okay, where this could be a problem, okay. But on a higher level, you've understood what I'm trying to say, everyone? What I'm trying to say is, it may not, sometimes it may be best to keep related data in the same split, right? So if I'm actually looking at the yearly distribution of something, and in 1 year the number of values are more, and I want to just figure out what is the maximum in that year, it may be a good idea to actually put it in the same split. Instead of splitting 1 year's value here and putting it across in this, if you have 2 year values, right, then what I get is not the yearly max, but the max of the split, right? Is that clear to everyone? If whatever monologue I just gave on the equal split thing? Anyone who is not clear, I'll explain it again. Great. So I'm getting a lot of smileys today. Thank you very much, guys. Clear, the bunkers is clear. Great. So yeah, keep on sending smileys if you're able to understand this. If there is anything which you're not able to understand, feel free to stop me. Okay, great. Thanks, Parthavan. Thank you very much. Okay, so now one challenge which we've understood is that dividing them into equal splits may not be the best idea. And if we do not divide them into equal splits, then we will surely get into this critical path problem. That's also clear to everyone. But even if we divide them into equal parts, then also we might get into, look at the usage of the thing, we will surely get into a critical path problem when we do non-equal splits. Is that correct, everyone? And if we do equal splits, we might get into a critical path problem here. Is this sentence clear to everyone? Or has it gone over your head? Okay, got a lot of smileys, so I agree, I understand it is clear. Okay, now anyone in the class, Tushar, Shriram, who are not in the last class, if for some reason you're not able to follow, right, please do not hesitate in asking. All of our batchmates have agreed that I take a little longer to teach something, so they have agreed, and they have said that it is fine. They are okay to wait a little long. So please make sure that don't hesitate to ask. Okay, thank you, Shriram. Okay, and thank you everyone else. Vinod, you are still with us. It's not too late for you. You're not sleeping anymore till now. Okay, so now these two things. Okay, great. So two things which we understood. One was that splitting is the natural way of doing things, but the challenges with splitting could be that splitting equally has its own challenge, non-splitting equally has its own challenges, right? And then you do a CAT. Okay, now these are the two very important things. The second, the more important thing, then another important thing comes in the reliability. One of the machine may fail, right? How will you make sure that the reliability thing is taken care of, right? That's another challenge, right? Isn't it, guys? Smiley quickly if you agree to that. If one of the job fails, then probably, thanks Sachi, thank you very much. So if one of the job fails, then you have a lot of trouble, right? You don't know whether you got the right answer or not, right? Because if you are looking at the maximum temperature in a century and the machine on which the hottest year was there failed, then you get inaccurate results, right? True or not? So reliability plays a very, very important role here, right? So that's very important. Thank you very much for be interactive in the class. I'm sure everyone will understand at the end of it. Okay, now so that's very important thing. Now failed jobs, who's going to handle, right? Now tell me, these are all running in a different machine. Who is going to run the overall job? Someone has to run this overall job also, right? Which Dilip would have written in his script that split this, do grabs are done here, then do this CAT and then final result, right? So no, Rajat, let's not get to job tracker. Okay, let's not. We are not talking about Hadoop. We have not reached Hadoop till now. Okay, let's try to understand who is going to do that overall job here, right? So that's one challenge, isn't it, guys? So the challenges which we have are, quickly, can you quickly write it down on the chat window, what all challenges I talked about till now? I'll also repeat it once again because that's all, those are the things which are important to understand. Reliability, one, splitting the file, very nice. Unequal split has its own challenge, right? Master job, very nice. Reliability, if one machine is down, very nice. Okay, one more thing, critical path. Incorrect results due to failure, right? Very nice. So these are the challenges, right? Now theoretically and practically also, this is all possible, right? You can write a very good framework, which I'm sure a lot of you who are hardcore programmers and I'll probably say Avinash and Ravi, I'll just pick these names, or Dilip, because they've told me that they are hardcore programmers. Scalability also is a challenge, right? Dilip tells me, right? Who have done a lot of programming in Unix. They will claim that if a company gives them this job, they will be able to do it. Okay. So yeah. So Ravi, I will agree when you send me this awk program by the end of this class. Okay. Okay. I'm just being a little early in the press, but I want you to send the awk program. Okay. Yeah. Okay. Thank you. No, not at all, Ravi. Not at all, man. Not at all sarcastic. I'm just, I know you guys last time also I had a class with you. I learned from you guys as well. So definitely you've shown me that promise. So please, so yeah. So coming back to the fact that these are the challenges which we have. Now, any great programmer or any great guy who claims that, I mean, not even claims, I mean, a lot of you people have been from the software background. I'm sure a lot of you will be able to create such a program, right? How many people think they'll be able to create such a program which can take care of this? Avinash says yes. Rajat also says yes. Rajat, I will come to that. Okay, Rajat Behra. There are two Rajats in the class, so please don't get confused. I will call Rajat Rastogi as Rastogi and Rajat Behra as Behra. Is that fine with both of you? Yeah. Okay. So Behra is asking me a question. Just confirm my understanding on responsibility challenge. Who will be doing what and when? Okay, Rajat, I will. That is not a very good question to ask at this point of time. Very soon we'll come to know that. Okay, but I'll quickly answer that. So there will be one overall job which will be managing all these things, splitting and then pushing these jobs on different machines and then doing a final cat and showing it. That's the overall responsibility of someone who has to do it. Then these machines have to do this grep. Someone has to do this cat, right? So we have, these are the kind of problems which we'll have. These are the things sure. So Ravi says difficult, not sure. Okay. Sync sort is what, okay, sync and sort, right? Okay. So with JCL and COBOL, Dipankar will be able to do that. Okay. Now, how many people think they'll not be able to do that? Time taking is what Ashish says. Great. So there will be a sorting also involved, right? Very nice. So I think by the time I reach MapReduce, right, you would have actually told me that. No, I'm not saying at this point of time. If I give you 2 days time to write something like this, so through ab initio I can do that, says Orca. Okay. So if I give you 7 days time, can you write this program and give it back to me, which can take care of all the reliability issues as well? Sriram says I can create a OLAP cube and get it done. Okay. Okay. So I'm sure some of the people can do it, some people cannot do it. They want to use different technologies for doing it. It is impossible to determine the failures, not speaking to each other, right? So yes, it is very difficult, right, Ravi? That's true. So now who does, so you know why do we need something else? Now, everyone understands? God gave Hadoop, why use stairs when you have a lift? Wow. Yeah, so Ravi says God gave Hadoop, why use stairs when you have a lift? Right. So very nice. Thank you very much. Thank you very much, Ravi, for that great piece of poetry is what I'll call it. I'm not very good at English, so please, wisdom is what Dipankar says, right? So that is a wisdom nugget from Ravi. Okay, my friend who is lift. Okay, so Vamsi is saying lift can stop in case of power failure. When we are over, what do we need to? Okay, so Ramesh is telling when we are over with, then we need to use stairs sometime. Okay, use stairs in case of emergency. That's why I'm telling you guys, learn awk. Okay. So not Hadoop is going to come to your rescue every time. Not every time when you're given a job, the data set will so huge that you will tell your management that I'll use Hadoop to do it. Okay, they'll throw you out. What you'll get in response is a pink slip. If you tell them that I want to look at these logs and use Hadoop to do this. Okay, so all of you should actually learn awk then. Awk comes very handy. Very few people know them. You can also boast that you know awk in your office. Okay, so definitely learn awk. Okay. Now that we've established the fact that there are some challenges with the traditional way, and we've also looked at them, that processing capacity of each machine, splitting the jobs, the critical path problem, reliability, failed jobs, who runs the overall job. These are the challenges, and so we got a lift then, right? And the stairs could be awk, but we got a lift, as Ravi says. That's where our way of doing things, the MapReduce way of doing things, helps, right? So Dipankar, are you clear? Why do we need MapReduce now? Let's not go to MapReduce is a key value pair of programming which will be used to do this some definition, and then you become some XYZ certified Hadoop developer. Don't just rely on that. Okay. So it's very important to know where to use it and where not to use it. Okay. So now can you tell me, if the data set is small and if the files are small, okay, let me ask that question later. Okay, not the right time to ask that question as well. I'll ask you that question by the end of this class. Okay, if I don't ask you this question, please remind me that you had to ask some question on file sizes. I'll ask you that and make that clear then. Okay, so let's move ahead and let's see. Now I have introduced the term MapReduce on this file, but I'll not talk about MapReduce still. Okay. I want to actually understand from all of you that I want to see what are the characteristics of such data. Okay. So before, now these are some equations which are written here. How many people by looking at this slide can understand what I'm talking about? Just tell me yes or no. Avinash says he understands. Rahul says no. Anyone who understands yes, just tell me yes. No, I know. I mean, you will not understand. That's why you are here, right? Sachi says 50%. Okay. Key value, I understood. Hash map, hash table says Vinod. Parthivan says no. So anyone who doesn't understand, no need to write anything. Vamsi says functional programming. Okay. Key value is the key for MapReduce. Okay. Ashish says functional programming there. Okay. Now guys, one thing which is very clear from the data set which we saw, and it will become much more clearer as we see more data sets, that what we were looking at are key values. Okay, right? Where key is the year and temperature is the value. And we need a programming model which can handle this very well, right? So that programming model is called MapReduce. But before we get to those terms, jargon, map and reduce, don't have to worry about that. Let me tell you what do we need to do first. Now the first thing which we need to do is extract key values from that data which we had, right? And create key values, which means that if some year comes, some temperature comes, year temperature, that year may come multiple times, the temperature may come multiple times. So remove all the things which do not form, which are not required from that data, come up with a key value pairs, right? Which is a key and a value pair, right here, K1, V1, right? Do not worry if these equations are not making things very clear to you. I'll just show you an example as well. Let's try to understand with the equation and then we'll go to the example, right? Now, next thing which we need to do is actually do a sort. Yes, we will. Vamsi, we'll go to that. We will exactly. Yes, key is always unique in nature. Now, let me tell you how we're going to proceed with this class. Okay. Now, right now we'll see this. Then we will go back to our example which we saw. We'll write a program, a MapReduce program, to actually take out those things which we talked about. Okay. Okay. So is that clear, guys? So just give me 1 second. I want you to actually look at this. I'll explain what is this list K2 V2, what is this K2 and list V2, and what is list K3 V3. Okay. So these are the 4 steps which we have, and I will just explain it. I want you to actually just keep this in your mind. Okay. Okay, so now let's look at that example once again, and then I'll show you what are we actually going to do here, and how we'll come back to this slide once again. Okay, for now you can understand that initially what we do from that data is extract key and value pairs. So these will be these key and value pairs. Then what we're going to do is we're going to create a list, okay, which will have the key and the value list, okay, which will show me that for each key, if there is a repetition of that value, we'll get those values here. So that's what we're going to do next. Okay. Then we are basically based on sorting and grouping them together. Okay. Now next thing which you're going to do is we will use a function which will do the actual thing which we want to do. If you want to do a max, if you want to do a sum, and those things we will do, and then finally we'll come up with again a key value pair. Okay. So now this is some. Okay, Dipankar is asking question, list K2 V2, grouping is from key within map. Yes. So now, okay, now Dipankar, that's a question which I'm not going to answer now. I'm just trying to confuse everyone right now. Okay, so that they have this thing in their mind, because this is something which they'll have to see all the time. I want them to become familiar with this term. So this is how it will be written in every book. I'll explain with an example. So within 15-20 minutes, this will become crystal clear. Okay. Sometimes it is good to have chaos. Okay. So now I'll repeat this once again. What I'm saying here is that initially we'll extract key and value pairs. Okay, from the list. Key and value pairs. Okay, just understand these are key and value pairs. Now we are going to create a list, a key and a list of values out of that. So key and a list of values will be created out of that. Okay. Now this will be done obviously by doing some kind of sorting and grouping from this key value pairs. Okay, so that's the second thing which we do. Then we use this list, which was the key and a value list, and do some. Just a minute, Vamsi. It will be clear. Okay, and then do some manipulation or some calculation on this thing to get another key value pairs. Okay. Now, when I'm saying all this, I know it is not clear to anyone. Okay. But I still want you to remember these terms. Now, as we move on to the next slide, and as we look at the examples, it will become very clear. Okay. So let's move on. No need to stop here. Ashish, all those things will be answered here. Okay. Yes. So Sriram is saying, so say I have this question I'm going to answer. Sriram is saying I have a location in each file and temperature for day in each file. Key is location and temperature is value. Right. That can be one of the key value. Right. That's right. So this level of questions I'm going to answer. I'm not going to answer output of map and input of reduce is different. I am not going to answer this question list K2 V2 grouping for a key within a mapper output. So all these questions I'm going to answer a little later. Okay, Dipankar and Vamsi and Ashish, just give me some time. Okay. How it's going to split in this case is also something which I'm just going to tell you, Ashish. Okay, just give me 2 minutes. Okay, let's move ahead. And there is you'll very soon understand why I have created all this confusion in your minds. Okay, so very important to create chaos first and then figure out if it is clear or not, right? Otherwise it will become very simple and you will go back thinking that you have learned everything. Okay, I don't want you to do that. Okay. Let's take this example. Now it will become very clear. Okay. So look at this example, guys. This is your input. Now you remember I put this key value here, right? So this is the splitting. Okay. So you've created all these. You have split those records as deer, bear, river, car, river, deer, car, river, bear. Okay. Then what you do in this, you say deer comes once, bear comes once, river comes once. Okay, so this is that list with the mapping which we are talking about. Don't worry about these terms which are there at the top. You will these shuffling, reducing, finalizing, all these things, terminology will become very clear very soon. Okay. Now what we do here is okay. So Raghu, Hadoop will do it. Hadoop will do the splitting. Okay. You can configure how big split and all those things are possible, but Hadoop will do the splitting. Now, Okay, so now does everyone understand this part? Till now everyone is clear what I'm talking about? This list K2 V2 is clear to everyone? First we created these key values here, K1 V1 values. Yes. Yes, yes Avinash. Okay, yeah, so now, okay, so Rajat is asking me why everywhere value is 1. Okay, it is 1 because in this case, in this particular record, deer came once, bear came once, river came once. If it was like deer, bear and river, okay, then it will be twice here. Is that clear, guys? No, it will, yeah, so it will come twice, but not number 2 will not come here. Okay, it will come like deer 1, another deer 1, something like this. You look at this one, right? This example, can you see? Yes. Car is coming twice. Yes. So this is how it will be done. There's no calculation happening here. Yeah, like car. Okay. Now the first thing which you do is you just thanks Ravi. Thanks. Ravi says very concise diagram and clear diagram. Honestly, very good. Okay. Yeah, Dhananjay, just wait on. Wait for some time. Okay. Wait for some time. All these things will become very. I have not reached that stage till now. Okay. Now, this is the key, this is the value. Right? So what we've done till now, okay, what we've done till now is that deer is the key, 1 is the value. Bear is the key, 1 is the value. River is the key, 1 is the value. In this record, car is the key, 1 is the value. Another time car comes, I write once again. Okay. Right? And then we write deer, car, bear as values here. Okay. Now what we do? We do some, now one thing which is important to do is, it will be good if we could do some shuffling and get these things like this. So wherever bear is coming, we'll take all those records and put them together. Okay, that's called shuffling. Okay, obviously you'll call it shuffling only. Okay, and you'll group them together. Okay, so you'll have, now what you have is, you have bear and that comes 1 1. You can look at it this way also. You can also write this as, let me just open a notepad. Some people who already know MapReduce will ask me, why are you not writing it in the traditional way? So let me just quickly open notepad and show you how it will also, it can also be represented. So it can also be represented as, okay, forgive me for these parentheses and brackets. Okay, I'm just taking a liberty here. Okay, so this part which is written here can also be represented as this. Okay, so this is grouping of similar items together and putting a value for those. Exactly. Right? So that's what Vamsi has told me. This is what we'll probably end up doing at this stage. Okay, is that clear, guys? Yes, Rajat, Hadoop does this for you. Okay, I have not yet reached Hadoop. Okay, so guys, I have not yet reached Hadoop. So please do not ask me questions on Hadoop till now. Okay, I'm just telling you a process which is slightly different than the earlier process. Okay, which we used, right? And then we'll see how Hadoop is doing that. Okay, Rajat, is that fine with you? Rajat, I mean Rajat Rastogi. Okay, great. So now this is what we'll get on this point. Okay, so for car, now Sachi is asking me a good question. How will write for car? So for car, I'll write like this. Okay, is that clear now? Everyone? Okay, for deer it will be same as deer. So any number of, so this is the thing which we talked about when we were on the last slide. Let me go back to the last slide and see if things are, the thing which was looking very difficult, mathematical kind of equation where I confused you, whether it is looking better now or not. Okay. Shall I go back to the last slide? Guys, if you don't mind, and I'll come back to this one once again. Let's see if we've understood something on the lab. Ashish, I'll not answer that question right now. Okay. Ashish is asking, why have we not done reducing in the mapping phase? Does anyone want to know this answer now? Other than Ashish? Okay, everyone is saying no, and some people are giving you a big no also, Ashish. Okay, so just unfortunately, this is there is a group of people. Okay, so I'll have to respect. Okay, yeah. So don't worry, Ashish, but I assure you this will be answered today only. Okay, is that fine, Ashish? Not now. I have not got an answer from Ashish on that. Okay, thanks. Ashish has given me a smiley. So thank you guys, and you have all the right to stop me from diverting from the topic. Okay. Okay, now we have a lot of questions. Let me read through those questions and I'll see whatever I want to answer now. Okay, so Dipankar says because value of same key may be in different split, right? That's very much possible, and that's why we have done this shuffling here, right? No, don't worry about Java list or not. This is not a Java list. This is just a representation here, Ramesh, where we say that this is a list of K2 and V2. So here is the list, right? K2 and V2 are the, so Ramesh is asking me, I did not understand list K2, V2, which means he did not understand. Now these are key values. That is clear to everyone. This is a list of key values. This is also clear to everyone, right? Right? And if I represent this part as what I showed on notepad, then this is a key and a list, isn't it? Is that clear to everyone? Yeah, sorry, Vamsi, actually it is written as bear and I pronounce it as beer because that's what I like better. Okay, so Vamsi is asking me, he's trying to pull my leg as well. He's trying to ask me, is it a beer or a bear? So it's a bear, but I like beer better. So okay, okay, okay. Now let me explain you what are these terms. Okay. Now everyone knows that this part which I have written here is a key and a value. These are key and values, right? These are simple values. There is no list associated here, right? This is just a record, which is there's no list. Everyone, yes or no? Quickly. Okay, great. Now let's come to this. Now is this a list? Vamsi, you can represent anything as key and anything as value. I don't mind that. Okay. Okay, you can say anything as key, anything as value. These are, if this is a key, these can be values also. Who knows, right? It's only after doing something which we'll come to know. But right now, look at it as a single record which has some values. Okay. Now this is a list. Everyone understands that, which has key and a value. Yes, from that context, Vamsi, that was not a key and value pair, right? Fine. But this is a list. Everyone agrees. When I say list of key and values, right? So deer, bear, river, beer. Right? Right? So this is a list. Everyone agrees to that. Now, when I say that this is a key and a list of values, this picture may not represent that very well. Right? So that's why I've written this. So this is where I say K2 and list V2. Is that clear? Everyone has got it now? The reason why I opened notepad, I could have done it here also. Great, right? So this is a list V2 now. Great. So everyone is saying more clear now. Thank you, Rajat. Okay, Dilip is also giving me a smiley. I think even in the slides also it can be represented as, yes, it can be, but it can be represented there. But what happens is then people will not understand this process of shuffling, right? So there can be one more thing, then it will add, some people will ask me what is this process called. Okay, so in the slide I think this is okay because we want to actually put them together, right? And I will use this notepad to tell you that how is this a list value. Yes, Tushar, what you are saying is right. It's not really a list. No, Tushar, what you are saying is not right because this is not really a list. Now it is, when I write it this way, it is not a list, right? This is one part, this is another part, okay, and say a river, and don't quote me whether I'm using the correct values or not. So if river comes here, then this is another part. So basically, this is not, now Tushar is asking me is this a list? This is what Tushar is asking me. Okay. Thanks. Parthavan says awesome explanation for MapReduce process. Okay. So before Parthavan, thank you very much. I really appreciate your words here, but just give me 5 minutes. I want to make sure that everyone has understood it, right? So great. So now this is not really this, because this list will not be there. These will be only this part. Okay. So we'll have these as separate things. Okay. Now, when we get to the next process, what we wanted to do? We wanted to do how many bears were there. Okay. Now, I also wanted to count how many cars were there. Okay. So what I do, I'll take this part, okay, and use a transformation here. That transformation could be key some function on this value list. Right? Is that clear to everyone, guys? So now this function could be a max function. This function could be a summation function or whatever. This is the process where I'll do the actual work, right? Okay. And this is where I'll find, if this is summation, then I'll find out this here. Okay. Is that clear, guys? Everyone is clear up to this point? This function which I've highlighted here. Can I get a round of smileys if everyone is happy with this explanation? Okay, great. Is there anyone who has not understood it? Because see, I'll tell you one thing, there will be many people who would have actually looked at MapReduce, they would have looked at YouTube videos, they would have tried everything, still they would not be very clear. So I want you to be very clear about after this class. Everyone should be very clear about this, right? Yes, in this context, Tushar, it is sum. The function is sum. It could be max, it could be anything. I mean, you may write any function on earth here which can do something with this value list. Okay. And finally create what? Out of this function value list, what will you get? You'll get again a key and a value. Right? If it is a max, you will get the max value here. If it is a sum, you will get the sum. If it is a mean, you will get the mean. Right? Is it clear, everyone? So this will be the output of this process. Okay. And then finally, what we're going to do is create this, which will be the list. This will be the final list. This will be a list of these K3s and V3s, right? So this is K3 and V3, right? So let me write those numbers here, K3 and V3. And let me write this K2 and list V2 so that everything becomes very clear to everyone. And let me write just before this where we started. So we started with what? We started with K1, V1. Then we went on to create a list of K2, V2, right? Then we went on to create K2 and list of V2, and then we wrote a function here. Finally we got this, and then we got a list K3, V3. Is this process clear to everyone? Anyone in this class who is not very clear about this process, quickly tell me. If everyone is clear, I can get a quick round of smileys for this. Pankar, you were telling me. Okay. Okay. So Sachi is telling me, let me fill gasoline for your Lamborghini. Buy a smiley. Thanks, Sachi. Thank you very much. I hope that Edureka gives me enough money to buy a Maruti 800. I don't dream about Lamborghini. Okay. Yeah. I'm a very poor guy. I was a failure in college and I'm a failure still in my life. Okay, and old as well. So Lamborghini is something which I don't dream anymore. Okay, great. So thank you very much. Okay, so Dipankar is saying I will contribute. Okay. So Vamsi is telling me, then you are the next guy like Siri Johnson. Don't do that, Vamsi, to me, man. Okay. So guys, okay. Now let's come back to this. Thanks for all the comments. Okay, I have already contributed by paying my fee. Thank you very much. I am really thankful to Avinash for paying that huge amount of fees which you have paid for this class. Okay, my children will be really thankful to you throughout their ages, because this is just because of your fees that they'll get some roti today. Okay, thank you very much. Thank you very much to everyone who has paid fees for this class. Okay, and I hope that Edureka pays me a part of that. Okay, but yeah, coming back to this. Now everyone has understood this part. Okay. Yes, I am getting a lot of yeses now. Let's go back to the previous slide where all of you got confused. Yeah. So is it making sense now, guys? Whatever I showed you here. Quickly, yes. Everyone has understood what is MapReduce? Okay, so everyone is saying this slide is clear now. So now, do you think it was a good idea to create that chaos in your mind then? To make sure that you don't understand anything and then you understand? Avinash? Okay. Any formal definition, can you put in one line any formal definition? I know you don't like definitions, chaos theory, pattern in randomness. I'll let my friend Rajat Behra, who is a PMP, give me a definition for this. I don't know any definition here. So frankly speaking, I have never understood these definitions. So I'll not be able to give you a definition. I've explained it to you, right? Why do you need a definition? If someone asks you in an interview, define MapReduce, tell them that I'm not going to define it. I'm going to show you what it is. Ask them the definition. Okay, no one is going to define you that. Vamsi, don't worry, I will send you. No, I know. So in the interview you can explain this. I'll send you a formal definition also. Okay. I know in interviews you will be asked such crap questions, define MapReduce. Okay. Okay, so Rajat is giving me the answer, combination of two words, map and reduce. Okay, yeah, that's the PMP definition of a manager for MapReduce, and that's really true, right? I mean, it's a combination of map and reduce. Okay, now what is map and what reduce? Get to the definition there. Then they'll ask you what. Okay, Dilip has given very good. Dilip, my friend, has helped you. You should say thank to Dilip, and you can be angry at me. Dilip said it is a programming model and process for processing large data sets on cluster computers. Great, clusters of computers. Dipankar says determining logical unit of data, grouping them together and performing some operation on it. Okay, guys, is that clear? Is this Dipank? Let's go back to our example slide and see, is this what we were doing? Thank you, Dipankar, for that definition. So Dipankar says, Vamsi, you can note down this definition. Okay, I can also copy and paste and send it to you. Okay, determining logical unit of data, grouping them together and performing some operation on it. That is map and reduce in probably 3 sentences with 2 conjunctions. Okay, and a comma. Okay, and finally 2 dots after it. Okay, so that's the definition. Okay, so is this what we are doing? Determining logical units of data, grouping them together here, and then performing some function operation here, right? Thank you, Dipankar. Rahul is telling, I will remember this only by car, river and bear, and hopefully with beer as well. Ramesh Chaudhary is saying, it remembers me of 3 Idiot movie where Amir Khan is asking about definition in class. Yeah, definition in class is very difficult one. Someone came to our rescue. Dipankar is laughing. Okay. I will remember my beer is what Avinash is telling me. Dipankar is, okay. So guys, now everyone understands. I know, see, I'll tell you one thing. None of us have come here to study. We have come here to get entertained. Okay. So whenever I get to studies, you start talking about beer and Katrina and all these things. And then people blame me that you are, okay. Yeah, Vinay, that's what I'm saying here. Vinay, I'm really sorry about that. Okay, let's come. Now we understand this. Okay, Vinay, I'm really sorry about that. I don't want to get into all this right now. So let's come back to the point. And Vinay is telling you, please come to the point and don't waste my time. Okay. So yes, Vinay, I'm really sorry about that. So let's get back to the work. So now we have understood this MapReduce. So Vinay has given me a smiley, so he was not all that angry. He was probably telling you guys that come to the point, and he was agreeing with me because I was also telling the same thing. Okay. So Vamsi is telling, but honestly, I wanted the definition to tell my mind about the whole process in one liner. So I'll repeat that that definition once again, and you should say thanks to our friend Dipankar about it. Okay, where he said, I don't remember that. Okay. Determining logical unit of data, grouping them together and performing some operation on it. Dipankar Vishwas. Okay. So Rajat has given me another definition and Vamsi is saying thank you to Dipankar. Rajat is saying MapReduce is a programming model that's well suits for dataset where only one write and multiple read and to pass data to arrive at same conclusion. Very good, Rajat. I think that's a very good definition. And the reason why I say that a very good definition because that's where we started with in our first class. That this is for streaming data access, which means you write it once and you have to read things and parse them multiple times to arrive, right? Great. So thank you very much, guys. So now I think all of us are contributing well here. Vinay, I am sure you like these two definitions and this makes the whole process much clearer, right? And you don't think that we have wasted a lot of time. We've just reached 1.5 hours, man, out of which we have had fun for half an hour. Okay, so not too bad, right? Okay. Okay, so let's go. Okay, thank you, Vinay. Thank you for the smileys. So now everyone knows what MapReduce is. Anyone in the class or in the world who doesn't know MapReduce? Everyone understands what MapReducing is? Okay, great. Let us go and see in. Great. So I am getting a lot of smileys here. So let's now you'll ask me, show me in practical, right? So let me show it to you in. Yes, it is Vinay like that. Okay, but let's not do that comparison here because that's not the right point to do that comparison. We'll compare that when we move further in our classes. We'll not leave MapReduce now. Okay, so let's go and look at things. How do they look like in a program? Now, though I promised you that I'll be using Hadoop streaming as well and show you in various languages, let me get started with some Java. Okay, now everyone knows Eclipse. Let me show the same thing happening in Java. Okay. Everyone knows Eclipse? This is a familiar thing to everyone? Okay, you want me to match the window. What I'll try to do is I'll probably increase the font size here so that it becomes much more clearer, right? Just give me 1 second. I'll try to do that. Which version of Eclipse are you using? Is the question Avinash is asking me. Avinash, I don't know, yaar. There is some version which works well, so I use that one. But don't worry, I'll tell you, Avinash. Just give me one. I'll tell you which version. I know how to find the version. Okay. Let me just try to find out if I can figure out a way to increase the font size. I am not able to find that. Anyone tell me, oh, go to editor is what my friend is telling me. Windows. Okay, Avinash, what next? Preference. Yeah, go down. I need to go down, right? There is a, no, wait. Let me just do that. Preference. Okay. I think it should be in general. Preferences Java is what Avinash is telling me. Okay. Then what? Editor. Okay. Where do I find the option to increase the font size? Syntax coloring. General text editor. Okay. Windows preference general. Yeah, that's what I thought. Text edit. It should be in general editor. Go to text editor. Okay. Great. So Praveen, I am there. Now help me out. Okay, got it. So I think we can just increase it a little bit. Okay, so is this much better, guys? Everyone is able to see this? Great. Fine. So let me show you this. I mean, now this program which we just saw is actually, Avinash, just a minute. I'll tell you which version are we using. Okay, just give me one second. So this is the ADT Eclipse version. So this is the version, Avinash, here. Okay, I'll probably send you this. You can download the same version from. We will say you can ask the support team. These people can give you. Okay. No, I don't think there's any reason. There's no reason why we are using the Android one, because just to tell you that there is a very popular Android program which Edureka runs, and my friend here is telling me to publicize that a little bit, so I'll do that. So that's why they are using this Android version. Okay, there's a very popular Android program here, guys. So any one of you who wants to learn Android or have kids who want to learn Android, ask them to join Edureka's program. Okay, thank you. Thanks. That was a commercial break. Okay. Okay. So I'll send you this version if you want, Avinash. Okay. Now let's come to this. Now what we just saw was a word count program. Okay. What we just saw was a word count program. Okay. No, there is no extra. So there is some. Vamsi, I'll answer that question later. Okay. We are not talking about Eclipse right now. Okay. Okay, Dipankar, that also I'll show you. Wait. I'll tell you one thing what I'm going to do now. What I'm going to do now is I'll show you this program, I explain you this program in Java, then I'll create a jar file out of this, then I'm going to run this same program on Hadoop and show you how the MapReduce really runs. Okay, this is version. First thing which we do is we define a job conf. Okay. Now we call it we define a new job configuration word count.class. Okay, you can set a name also. This is optional. Okay, word count. Okay, no need to worry too much about here. Then you set the mapper class. Okay, conf.set mapper class. Okay, so this is the class in which we set the mapper class. Mapper class is this map class which you've defined up here. Okay, this is the map which we're talking about. Okay, now if we go down, we also define the reducer class here. Okay, then we set the output key class. Okay, now what will be the output type when the output comes out? We know the output is a key and value pair, right? We know, everyone knows that from the last slide we've seen that, guys. Is that correct, or is it not? You don't remember that? I want an answer from everyone, guys. Great. So yes, great. So now we know that the output, so here, this is where we define what will be the output type. Okay, the input types can be different, the output types can be different. Okay, now in this program, since we have text as the output key, where it could be bear, dare, whatever, right? And int writable is a special type of int for Hadoop. Okay, and since it is an integer output, we will be using that, right? So Dilip, my friend, is trying to help me out. Thank you, Dilip. He's telling me here are the 4 basic parameters of mapper, right? Long writable, text, and int writable. So we'll talk about them a little bit, but let me explain you from a top level where we are looking at the black box, where we are just talking about what is the output and what is the input here. Okay, we'll go into it just now. Just in a while we'll go into it. Okay. So for now, understand that the output is a text, the key output is text type, the value output is int type. Okay, in this particular program which we just saw, where we are talking about bear, dare, and whatever, right? Similarly, no, there is no reason why we have defined output before input. It doesn't matter. Avinash is asking why we have output before input. Okay, it can be in any order. All these can be in any order, right? There's no problem with that. Okay, is that fine? Now, finally, this is where we set the input types. Now, as I promised you right in the beginning of the class that I'll be discussing about different input types and different output types, input formats. Just assume that right now we are setting the text input format for this class, for the input format. Okay, the set output format is text output format. Okay. These are the default values. Okay. So don't worry about these are the default values. We'll look at more types when in the next class probably. Okay, where we'll talk about sequence and all those things which I mentioned in the slide first. Now this is very important, and this is one of the things which you should really look at. This is file input format that's .set input paths, conf and new path, which means this is the path from where I'll pick the input files, okay, on which I'll be doing the processing. Okay, and arg0, everyone knows what it means? Everyone knows that? Anyone who doesn't know that? Okay. So basically command line argument number 1 will be arg0. If you're passing command line argument, that's right. So arg0 will be the first argument which you pass along with that command. Okay, Gaurav, is that clear? And arg1 will be the second one. Okay, so when you run this program, you will say program name, then input file path and the output file path. Okay, that's how we are going to run this. Okay, if you remember last time we showed you a jar file and we showed how to run a program. From that we will doing the same thing here also. Here these are the inputs and the outputs of that. Okay, we'll just do that as well. We'll show you this. Okay, for now let's try to understand this program. So this part is clear. Then finally we'll say this is the run job method. Okay, this is the run job method in the job tracker. Okay, this will tell the job tracker to run this command. Okay, now let's go up. We'll understand more of this. Let's look at this map class. And what is it doing? Is it doing really what we showed in the presentation just now? Okay, let's try to find that out. So basically we have, now this is when we say implements, which means this is what? This is a class or an interface? Whoever knows Java has to answer that answer. Give me that answer. Okay, great. So our class map, okay, extends the interface, okay, extends a base class and implements a mapper interface, right? Is that clear, guys? So this is the wave class and this is the interface, right? Everyone is clear with this? This much Java everyone knows? Exactly. Extends wave class and to implement method in mapper interface. Exactly. Okay, just a second. Is my voice not clear to everyone? There are some people who are saying voice is not clear. Great, great Dipankar. Okay, fine. Thank you. So is this clear to everyone now? Right, what we are doing here? This is our class which extends this class and implements a method mapper from the interface. Okay? So that is how, and these are generic inputs, generic types. Okay. Now when we come to this, we talk about a method map, okay, which we are overriding, right? We are overriding a method map, okay, and defining it here, right? So we have inputs, long writable key, text value, these are the inputs, and there is an output collector which is text and int writable from the map. And reporter is basically, if you remember when we run a MapReduce program, it tells us that 0% done, 2% done, that reporting which happens on the command line, right? On the screen. We will show you that as well. Do you remember that when what happens when we run a MapReduce program? It shows on the screen that, okay, 0% done, 10% done, reduced process done. Remember that? Okay, Rajat. Let me explain. Let me explain that one. So these are the input types. This is the output collector, okay, and reporter is the thing where we actually report what is happening. Okay, yeah, it is a progress updater. Exactly, Rajat. Rajat has given me that answer. Thank you. Great. So is this clear, everyone, guys? And it throws a IO exception. Now throws. Everyone knows what throws is. Whenever it finds the IO exception, it will throw a. Whenever it is not able to find that input file, it will throw a IO exception, saying that file not found or something. Okay. Is that clear, guys? Everyone? Very simple till now. Quickly a yes and or a smiley. Very quickly. I want a yes from everyone. Great. Very nice. Very nice. Now, what we're doing here is we're saying a string line value to string. Okay. So basically, if this is my complete line, okay, it will go in this. You convert this value into string using this. Okay. This is my complete value, and I will convert it into a line using toString method. Okay. Is that clear, guys? So this, let's see. I'm fine. I've written twice. Okay. Great. Now, string tokenizer, we create a tokenizer out of it. Okay. Now, when we tokenizer means it will split these values. Okay. On what? Can someone tell me that? Avinash has sent me something. Okay. Okay, great. So Avinash has sent an example for everyone. Great. Let me just pick that example. On a delimiter, unless till the end of line, Rajat is telling me, very nice. Default delimiter is space, each word. Okay. So I've got my answers here. Okay. So string tokenizer, this is test. Okay. Very nice. So Avinash has given me an output which I'll copy and paste. I'll try to do that. Okay. And I really like this way of learning, guys. Everyone is contributing. I really like that. Okay. So now, for people who are not very familiar with Java, Gaurav and all who have not been able to do a lot of practice, this is what Avinash has sent us, and I'm sending that to you. Okay, very good. So everyone has got this here, where he has written a quick program which says string tokenizer st new string tokenizer. This is a test, is the complete string. While it has more tokens, println will print in the next token. So it has clearly told you that this is a test, has been splitted into 4 parts on the delimiter space by default, and every delimiter has been printed here. Okay, so this is a test, will come one by one. Is that clear to everyone, guys? Let's give a quick round of smiley to our friend Avinash. Okay. Dipankar has given me said good one. Okay, thank you Avinash, thank you everyone. A lot of people are saying thanks to Avinash. So now we have learned this part. Okay, smiley for Avinash is what Shriram is saying. Okay, okay. So Avinash gracefully accepted all the thanks. Okay, very rarely he does that. Okay, but okay. So Avinash, just pulling your leg, man. You are my friend. Okay, so okay, now looking at this, now that Avinash has told us everything, we know what is happening here, right? So let me show you what is happening. So if we had this value, right, that I am fine, okay, so this is the value, sorry, this is the value. Okay, so I1 am 1, like we saw in the last example, very similar to that. This will be the output of this. Is this clear to everyone, guys? What is happening here? So what you're doing is, whenever you get a value, you say new value will be assigned a value, new int writable, output.collect. Okay, value and new int writable. So this is what is going to make something like this. Whenever you find a new token, in this I is a token, am is a token, fine is a token, then again I is a token, am is a token, fine is a token. Every time you find a new token, you print new int writable 1 along with it. Okay, is that clear to everyone, even to the folks who do not know Java? Ravi, are you still with us? Vinod, are you still with us? Great, great. Okay, so the guys from the EST time zone, I know it's a little late, but we'll quickly be able to finish this off. Okay, great. So now this is what we'll get as output. Okay, is that clear? Now let's go to so this is what will finally happen, as I told you. This will be done automatically by Hadoop itself. Okay, so this will be converted into I11, like we saw in the presentation, right? Is that clear, guys? Something like this is going to happen. I11, am11, fine11. This will be the thing. Okay, keep on writing yes if you have understood it. If you have not, then keep on writing no. Okay, great. Let's go to this. Okay, now and see what is this reduce thing doing. Okay. Now the reducer input is again the same thing, the text, which is I, and int writable. Okay. Now look at this, the input to the, yeah. So this is what we outputted from here. The same thing goes as a input to our reducer function, right? And finally the output will be text and iterable. Okay. Now if you look at this method, what we have here is text, which is a key, and then there is something called an iterator. What is an iterator, guys? Quickly. What do we need here? List. Right? No, it is, okay. So it's a list. List of values is what Vamsi tells me. Oh, iterate over the list. Very good. So iterator will iterate over the list. So as we saw, right, this is the input which we'll be getting here. So as we saw initially, K and list V2, you remember that thing which we did? Where this is the thing which we had, right? So this is where we use the iterator thing, right? Is this clear to everyone, guys? The relationship between this part, this mathematical equation, and what we are doing in Java here? Quickly, yes, good, very nice, very nice. Okay. Now, then we go here and say IO exception, throws IO exception again. Again, text and iterable are the outputs, and reporter, same things we saw. Now what we do, since we had to do a sum and tell you how many times does beer comes and how many times does bear comes and how many times does car come, what we have to do is, on this values, this was the iterator, has next tells me if it has a next value. Okay, it will come false when we reach the end of the list. Okay guys, everyone who's new to Java, this is how it works. Okay, what you do is sum plus value next. So the value of the next, you will get it here. Okay, so this will take you to the values next, and this will give you the value which is there in the next. Okay, so the value here will be 1, right? Every time on this list, sum is equal to sum plus 1. So every time you go through this loop, you will come up with one addition into it. If this was the input, then it will come with 1 first, then it will come with 2. Finally, when we get out of this loop, when we have finished this list, it will come with something like bear 3. Is this clear to everyone what is happening here? Quickly, yes or no? So now if this is clear, then you've understood the MapReduce in Java as well. Okay. Now let's look at our original program. If we've understood everything here, yeah. Ravi, I'll answer that later on. Okay, it's a old API. Okay, it's a deprecated API. Okay. Now where is the flow of sorting of data take place? Okay. So this takes place. Okay, so we will also be looking at there are some more steps which happen. There is a very simplistic program. It's the shuffling steps itself. Okay, yes. In the shuffling step itself, the sorting also happens, and we will be looking at the other things also, partitioner and combiner, which we'll look in the next class. Okay, let's not go into that. I'll also tell you where we need it and what are the limitations with this program. This is a very simplistic program. Okay, guys? Is that clear? This is clear to everyone? Now, what I'm going to do next is, great. Can I quickly get a round of smileys from everyone? Now, till now, within this 1.5 hours, what you've understood is traditional way of doing things. Then you understood what is MapReduce. You also understood how to write a MapReduce program in Java, right? Isn't it great? Right. So now let's see how do we actually run it in a cluster, right? So before that, let's go to our weather data. Okay. Let me show you the same program which we saw the initial data which we saw. You remember that the first data set which we took out, which was looking something like this. You remember that, guys? I don't have to explain these things. I'll go down into this program. I'll quickly go down into this program and show you the same things which we saw earlier as well. Okay. There's one difference though. Same thing, create a set job name. Now here I've put a quick note for you. There the class was different, right? Set output map class was different. These are not default here, so we have to define them. Okay. So these properties had to be defined. Earlier it was not defined at all, right? So these are the two new things which have come up in this program. I want you to look at these things when we get out of the class. I'll be sending you both these programs. Default input types, there was what? Text and iterable. You remember that? Yes, Vamsi. Now in this case, the output is what? You have to give me a text only, right? What is the maximum temperature there, right? Whether it is, I will tell you what we're going to do with this. So that's why we had to redefine this, right? So that's the only difference. Other than that, there's no other difference. Everything remains same. Same way we define the input file path, output file path. Let's go to quickly to our map function and see what we're trying to do in this. Okay. So in this, what we're trying to do here quickly is that again we do the same thing, value to string. We got everything in this line, right? So this becomes a string type, this complete thing. Now what is this doing? Line substring 614. Okay. This guy tells me where is the date. So date is here, right? So you pull out a substring out of this, and this is how you get the date value here. Is this clear to everyone? This line 36. What we're doing here, the line contains this whole thing, whole record, okay? And substring 6 to 14, this guy will contain your date, okay? Similarly, we'll get the minimum temperature and the maximum temperature and the minimum temperature. We store them into float. So what we do is, first we do this, 39 to 45. We're just being a little, why are we doing this guys? 39 to 45 and not the exact number? Any idea? So, yes. Sriram has a very good question. Here we are able to apply substring as we know the file format. So most of the times you will be knowing what file format are we having, right? The data set may not tell you what this is, but data will be dumped in a specific format. So you will always have that. Sriram, some way or the other you'll be able to figure out what value is what. Though it may not be written date here, but you'll be told that okay, this is delimited by a comma, or it is not delimited by anything. It can be completely splitting, right? Is that clear, Sriram? Okay. Well, this is not a structured file as such, right? It is actually unstructured data, right? There is a log file, right? There are other things like if you have image file, what do we do then? Don't worry about that question now. I'll answer that question next time. Okay, Sriram? For now, okay. Sachi is asking temperature the numeric data, then why the output parameter has to be text? The output of this program I have not yet defined. So I have not told you what I'm going to dump, right? I'm not going to dump, right? So just hold on. Okay, yes. So now what we're doing here, and the reason why we've taken a range, it is not 39 to 45, it is 6 values, right? Why we've taken a range is because sometimes the temperature may be 33. You can have say 99, 100 also, right? So we want to make sure that we take a range in which it will come, right? To accommodate for exactly Ravi. Thank you very much. Right. And Dilip, my friend, is telling me just like cut command in Linux. Exactly, Dilip. So in cut command, what we do, we take out specific columns from a file, which is delimited by some parameter. Okay. Dilip will also send us the cut command. I can also show it to you, but right now that's not required. Okay. But remember, awk and cut is something Dilip is going to send us. Okay. Yes. So it will take one line per record to accommodate extra digits. We do this, and then we do a trim. Trim will remove all the spaces out of this, and then we make it a float. Parse float will make it a float type. It is a text type right now. From a string, it will convert it into a float. So you'll get the temp max here, right? Is that clear to everyone, guys? And then we have a temp min where we'll be trimming it again. We get a temp min again. So this is how we get it. Okay. Is that clear, everyone? Now, what I also do here is that I put a condition which says if the temp max is greater than 40, I'll call it a hot day. So now it will be clear whether that my purpose of this was to declare whether it is a hot day or not. That's why we are using, whoever asked me that question, Sachi probably, that temperature is why are we using a text type? Okay. So what we are saying is output will be hot day and date. Okay. And value of, based on the value of this, right? If the value is this, it will be writing this. So what are we going to write? We are going to write hot day. If it is more than 40, we are also going to write the date here, and we'll also put the temperature out. Okay, these are the three things we are going to put here. Similarly, for a minimum thing, if it doesn't fall in that, there's no output for that record. Is that fine, guys? If the temperature is below 40 and between 10 and 40, there's no output in this program for that. Okay. Now, if the temperature is less than 10, then we'll write cold day and this, right? Is that clear to everyone, guys? So this is the output here. Okay, quickly, yes, can I quickly get a round of smileys? We are almost there. And then I'll also give you assignment on this. Everyone is clear? No one has a confusion here? Even the people who did not know Java are able to figure that out? For each record we are doing that, Avinash, up. Yes, Dilip, we will be sending all these, see all the code which is there will be given to you. Okay, all the code will be given to you. There are many more other programs which lie in your LMS. I'll show you them as well. Okay, so don't worry about whether I'll get the code. You don't have to note down anything. So Tushar is saying I could understand even if I don't know Java. Very nice. That was the purpose of this small exercise. This example is clear, but I'm not clear. Will be so structured that we know the exact location. Okay, so Vamsi, don't worry. I'll show you more examples on how to do that. Okay. Now this data is a real data. This is not something beer something which you have created, right? We got that data from a real location, right? You remember that we got it from that particular website. Vamsi, you remember that? Usually you will be dumping that data in some format. We will be sending everything to you. Don't worry about sample code and everything. Okay. Now let's go to the max temperature reducer. This is the reduce program. Now in this reduce program, I am not doing anything. I am just dumping the values. Okay. What I want you to do, so what this means is that fn which I had defined, there's no fn here, right? There's no fn here. I'm just dumping these values. Okay. I'm not doing any function here. So it will straight away dump this. There's nothing. If I have to just dump whether it is hot or cold, I don't need any function here. Okay. But if I had to say, do something like this, where I had to say which is the maximum temperature in a particular year or in this complete thing, which is the maximum temperature, okay, then I have to write a function max here. So then I have to implement that, and that is your homework as well. On this data set, you have to find out which are the maximum, what are the maximum temperatures in particular year. Okay, is that clear to everyone? How will you do that? Very simple. Is everyone clear on that? This homework? Can I get a quick yes? Great. Very nice. So this is the data set. I want, yeah, so let me show you the LMS, Learning Management System, show you where all these things are kept. Okay. Now everyone is asking questions that where will I find this data, recording, everything is here. So there is this word count program for Eclipse. This is the project. Okay, there's a temperature thing also here. This is a slightly different thing, but very, very similar. We'll be sending you this data set also. So all these things are there. So all these assignments you have to do. Okay, this is the program which we saw earlier, right? And you can quickly download it like this. So when you have to load this project in Eclipse, when you download Eclipse, so the complete environment will be created like this. Okay, is that clear to everyone, guys? Quickly, can I get a yes? Okay. And I also want you guys to do this on your own. Okay. I will monitor how much support you're taking from the support team. I'm going to monitor that. Okay. So now that we are here, right? Okay. So you have to do a lot of these things on your own. Okay. It's very simple. I'm sure you'll be able to do it. Next step, what we're going to do is we are going to create, how does this? Yes. So Vamsi, this is the thing, just thing which I just showed you on the LMS. If you download this part, it will show you how to set up MapReduce on Eclipse. This guy is going to do this. Okay, Vamsi? Great. So let's get back to the class once again and see what we're going to do next. Okay. Now the next thing is, now that you've created this program, we will be creating a Java archive of it and we'll be running it on our Hadoop. Okay, that's the next step we're going to do in this class. Okay, isn't it exciting? Now we're going to actually run this program on Hadoop, on our cluster, on that data set which we had. Okay, so the complete process will be completed and then we'll go to the next things. So let's go to our cluster now. Quickly look at the process of creating a jar. I'll also be sending you a quick video which will show you how to create a jar out of it. Yes, Vamsi, thank you very much. I'm getting a little late for the doctor's appointment. Thank you very much for your concern. I'll just take 5 more minutes and then after that I'll take a break. Okay. So what I'm showing you here, look at this clearly. We are creating a jar file out of this. Okay, so this is a jar file. Okay. I will also be showing you, so this is the jar, in this path we are creating it. I'll also be sending a quick video of how to create a jar file and a document as well, so don't have to worry too much. I'm just showing you how it is done here. Now let's look at which is the main class of this jar file, right? So we are looking at the weather data. Is this clear to everyone? Quickly, yes. Thank you, Vamsi. Thank you very much for your concern. The old man will give you a lot of. Okay. Yeah. So let's look at this. Let's look at this one, and this is the jar which we've created. Now, what are we doing here? We are FTPing this into our cluster. So this is the FileZilla thing. We've put it from here into our cluster, right? And in our cluster, we'll see that we are able to see this or not. So we got it here. Is this cool, guys? Is this clear to everyone? What we did, we created a jar file, exported it from our system into the cluster, and this is where we got it. And this is the jar file, this is the data set. Okay, so the data set is weather data 2. Now let's look at the data set quickly. So this is the data set which we are looking at. These are the dates and the temperatures here. Okay, now we are going to do a Hadoop DFS. You remember this? We showed it last time. Copy from local. We'll copy everything into DFS. Here. Right? Is this command, you remember this command? Let's look at this in a file system now. This is our HDFS file system. We got this file here. Great. Quickly keep on writing yes, guys. If there is some confusion, just keep telling me. So what we did, we copied this jar into our HDFS. We copied the text with the input file into our HDFS. Okay, now we are going to now we are going to do this. Yeah, so now we are going to run that program. What was the Hadoop jar? Now what are the inputs and outputs there? arg0 and arg1, input file path and the output file path. Right? You remember this now? These will be the arg0 and arg1 in our program. Right? Cool. Very nice. So yeah, let's run this program and see what is happening. Okay, so now it has started running. Ramesh, I'll tell you that as well. Okay. So Ramesh, I'll tell you that, not now. Okay. Now let's look at this. What have we got? We've got one. Okay, great. So it has told me these are the cold days. Okay. It didn't find any hot day because probably the number which we've set is a large one. It would find only cold days. Okay, that was the data set on which we had that. So this is how a sample program runs on Hadoop. Is this clear, guys? Everyone, the steps? Great. Wow. So now I know some of the things will not be very clear. Sachi, I'll take your question just a minute. Okay. Rajat is saying it's not clear. Rajat, please ask me a question. And what I'll do is, for today, we will stop here and we'll go into more things. Where is the class name? Okay, show him the class name from the Hadoop jar. Okay, good. So last time we saw that. Okay. So here's the, no, don't worry. I'll show you the class name. So this is the class name here. Now let's look in that jar file. Last time we looked at all the classes which are there in the jar file. Okay. This is the class name here. Okay. Just, okay. Now there is a way to show you that, I'll show you later. Okay. Just, this is the class name which we used from that jar. Since the jar had only one class, it ran the default thing. Is that clear, Rajat? Yeah. So the Pankar, you will get all these things easily. Okay. Don't worry. You can get touch base with Rajiv. He'll give you all this. Okay. Rajat, is it clear? Great. Okay. So everyone is clear with what we have just done. let me quickly tell you what we've just done before I rush out. Okay, and I'm really sorry guys, I had to leave today a little early. Next time I'll compensate for this one. Okay, so what we did today was we understood, quickly keep writing yes or no. I'm not taking a quiz also today. Next time I'll take a quiz on all these things. So quickly we saw where the applications of a MapReduce kind of program will be required. We looked at a large data set. Okay, you were supposed to ask. Thank you, Rahul. Thank you for that question. I'll ask that question next time. You remind me that next time. Okay, I'll show you a larger data set and I'll show you what to do. I'll also send an email on this today evening to everyone. Okay, so what have we done today? We have quickly looked at what all is. We started with a large data set. We saw a weather data set. Then we looked at what are the traditional ways of doing it. Our friends have promised us that they'll send us awk and cut there, right? So who are our friends? Can they quickly send me a smiley? You're going to send me the awk command on this data set to do this particular operation which I've done through Hadoop MapReduce. Dilip has given me a smiley. Ravi is hiding behind somewhere. Ravi is saying not me. Ravi, you have to send me that awk command here. Okay, Avinash is also going to send me that. Okay, so same thing has to be done in awk. Okay, and yes, Vinay, we will have a MapReduce class only next Saturday as well, right? So we will extend this further. I'll tell you what I'm going to cover there. Okay. Now, some of you guys were also supposed to write a blog last time, right? So, okay, no problem, Ravi, at all. Okay. So yeah, so we will be integrating a forum also. Thank you, Ravi. Thank you very much. So Ravi is telling me I will show for sure this blog thing. Okay, thank you, Ravi. So so now what I want you guys to do is, see, one exercise, if you don't mind, will be to write a blog on this class itself, whatever you learned here, right? Step by step, you can tell us. So simple thing could be take a quick data set, use awk to do this traditionally, then use 2 examples and show us how does MapReduce work, and then write a program and then create a jar file and then do this thing, right? Whatever we have learned today, if you write a blog out of this or a document out of this, I'm sure you're going to learn everything out of it. Is that a good idea, guys? Can you find out some 2 hours today after this class? Everyone, can you promise that? After this class, you'll write down whatever you've learned today quickly after this class, okay? And you send it to me. I will look at each and every one and I'll send my review comments, okay? So you can send it to, right? So please write whatever you've learned today, okay? Write it back to me. I will correct that as well. If there is anything I see that someone has not understood it properly, Gaurav, Rajat, everyone, Amrish, everyone has to write this, okay? And send it to me, because this is a very, very important concept. Lot of things, Dipankar, would not be very clear if we lose this here, right? So everyone, please, okay. So do it on Sunday. Dipankar is saying I'm going to a lake. Okay, sure. So please do that. Send it back to me. I'll review that. Okay. Okay, guys. So I think this is it today. Now, okay, this is it for today. Thank you very much for your time. I'll be right here back with you this same time next week.